Hi everyone, hello. Okay. I'm just setting up some boilerplate for our tests. Wait, what's that? The destination entry point name is main. No entry point was found. What? Here it is. What do you want? Yeah, I mean, it should be just fine. Yeah, we have build, we have a file, we have this, we have that. Oh, workspace target program. Oh, wait. What? Is this wrong? Ah, okay. Of course, yeah. In order to be able to run the metaprogram, you actually need to run it, right? Of course. In order to be able to run the program, you need to run the program. Whoops. A ptr.jai. So what do we have here? We have a, which is a struct. We have a test struct that accepts a as a parameter, just like embeds it. And then we have some test code, right? It creates a on the stack. It takes a pointer, and then it assigns a to a pointer, right? So t takes a as a regular type, and we assign a pointer to a. And what Jai does is Jai lets us auto dereference that. So under the hood, it literally does that, right? This happens under the hood implicitly. And what I want to do is I want to detect this behavior and maybe not entirely ban it, but at least report when this happens. So in case you debug maybe some like segmentation faults that are related to access and invalid memory location, you can see all of the pointer dereferences that you might not have intended to do. So that's our plan for today. Yeah, and we need to do that, but we also want to exempt a valid dereferences. So we want to exempt explicit dereferences. So this should be detected, right? Detected and reported, and explicit dereference should be fine. Yeah, that's the goal. That is the goal. Yeah, welcome everyone. Welcome, welcome. I see people are coming in. Hey, Tool. Nah, YouTube suggested me your stream and I'm not following. How could you? Yeah, I mean, yeah, discoverability on YouTube is literally the worst for streams. And it makes sense, right? Because streams are very expensive for the platform. So they probably want to have it as a feature to compete with Twitch, but they definitely don't want to advertise it, right? Hey Jumpy, hello, hello, hello. Welcome, welcome to the stream. But yeah, you found me now, so welcome to YouTube. Yeah, so yeah, that's kind of the thing. Ilionte roasting me for me being a fan of automatic dereferenced. Got to a point where I was just thinking about it and I realized that in this programming language you don't actually have to choose between having automatic dereference and not having it, because you can literally just write a meta program that can detect it at compile time, and if you don't want any implicit dereferencing, you can just ban it on the user space. Isn't that crazy? I think it's kind of crazy, right? So I guess we can try to do that. Right, let me just condense this down, and yeah, here's our handle type check. Right, so how do you even start it? I guess we kind of go so because automatic dereferences, they can literally happen anywhere, right? They probably can't happen in the procedure headers if you think about it, right? They definitely can happen in default initializers here. You can definitely automatically dereference shit here. And you can absolutely do it in procedure bodies, right? So this is what we call like a non-imperative scope in Jai. And this is like an imperative scope. I guess we need to check all... I actually don't know how you get messages about default initializers. Do you get them as procedure bodies? Because, under the hood, Jai creates an initializer of procedure. So maybe that's what you get in the metacompile loop. So we'll have to see that. But for now, I guess we'll start with the simplest possible example is you get procedure body, you get a statement, and the statement looks like this, right? And we want to detect that. Cool. I like automatic dereferencing. I do it in my latest transpiler. It's so easy for the compiler to know, and it feels way more fluid always. Yes, that's why modern languages do that. Just because it's so convenient. Yeah. I mean, exactly like that, yeah. It's just very convenient not to have it. But you know, some people don't like it because it can definitely lead to some oversight when you dereference something you didn't mean to dereference to dereference. Like I did yesterday with my Vulkan code, where I screwed up. So yesterday I had a situation where I was manually writing struct definitions for Vulkan, and the struct that should be accepting this, I accidentally wrote it like that. Yeah, but the compiler let me have it because it would just automatically dereference a pointer. And this pointer should not be dereferenced because later it would the internal Vulkan driver would read it as a pointer. And so I would get crashes for reading from invalid location, right? And if Jai didn't have automatic dereferencing for structs, I would be instantly getting a compile error, right? Because for numbers, you can have it. So if you have a number which is S64, right? And you try to like have a number and then you try to do this, that n equals like pointer to b, you can't do that. Jai won't let you dereference this, right? You will be getting, wait, what? Yeah, this is not a tab. Yeah, you see mismatching level of indirection. So you can only automatically dereference structs like that. You can't dereference primitives. And so if it was also the case for structs, I would be catching that error, that mistake that I made way earlier. And instead of that, I spent 45 minutes doubting the X11 code because, you know, X11. So yeah, that's what we'll be exploring today in ways to optimize, not optimize, but automate it. And to start, I will be getting procedure bodies and iterate over all the statements in procedure bodies. That's what I will be getting. And to do that, we can go to compiler module, right? In compiler here, and we get a message type checked. Yeah, there you go. It has a message under the hood, and it has declarations, procedure headers, procedure bodies, structs, and some others, right? How do you, yeah, so you can do, expand it a little bit to refresh our memory on how it's structured. Here we have arrays, blah, 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 so that we don't get all of that if we don't want. Different things, even if they're not defined at top level. Okay. Yeah. If you know for sure the data is bound to a name in a top level scope, you could take a policy of just looking at the declarations. Yeah, okay. Procedure bodies. So I want to iterate over procedure bodies for now. We didn't want to have a zillion arrays. Yeah. What's that? Oh, okay. This is for top level statements. Top level statements. Probably don't want all. Right. Anyway, so here we have a message type checked. So for message procedure bodies, right? What do you have in the chat? But would the arrow operator really fix that, or could you just have easily mistyped, or am I I mean, in my case, the problem was that I literally wrote the type of the struct incorrectly, right? And so I was trying to assign a pointer to x11 display to struct that should accept a pointer. But since I mistyped the definition of a struct, I was assigning a pointer to display to a struct that just accepts the display. And so Jai would dereference that pointer, right? And if instead I got a compile error like, hey, you're trying to automatically dereference a pointer, or you're trying to pass a pointer to something that doesn't take a pointer, I would start questioning myself like, oh, why am I dereference the pointer here? And oh shit, that shouldn't be, this like shouldn't be a real struct in the first place. So yeah, I just messed up the struct definition. Let me fix it real quick. Right, so yeah. Hey Puka, hello, hello, welcome. Quote, true. All of the vowels on my keyboard work like what? Oof, congratulations on the new keyboard, I guess. Yeah, procedure bodies, let's just PB. Let's just print stuff. So like print. Oh, I actually want to do import print vars. Print vars is a special module in Jai that's like just prints an actual stuff, an actual like variables, very convenient. So you can just do PB that and dereference that shit. To use, okay, it's not a. Wait, what? Ah, yeah. It's print vars. Cool. So what do you have here? N is not a member of test. Oh, yeah. So I deleted that. Okay, yeah. So we get procedure bodies. Ooh, shit. We get a lot of procedure bodies. That's crazy. I think Emacs is about to die. So let's... no, it's over. Okay. That's many lines. That's a lot of lines of code. Yeah. So compiler, we have procedure bodies. It's type checked of code procedure body. So we need to like unwrap it. Right, so type checked is, yeah, expressions and sub expressions. So how did I iterate over it? Let me do build alt here. I'm doing that actually. So type checked procedure bodies, right? And I get body is an expression. And after that, I assert that the block is not null, and I actually get statements of the block. Makes sense. Let me just retype it so I keep it in my muscle memory. So again, we get body itself, which is expression. Expression. Then we get block is body.block. Hey Dunka, what's up? Hello. I think that's it. Of block statements. And you know what I also want to do? I want to kind of restrict it to my main for now. Я послал видос на рендер, если хочешь небольшой тизер. Oh shit. I don't want a teaser, but I will definitely... okay, I see. Is this a thumbnail or what? Yeah. I will definitely watch the whole thing when it's on your YouTube. For those who don't know, Doomka is like world's first Half-Life 1 hitless, damageless runner. Hey Leonte. Yeah. Yeah. I wonder. Yeah, maybe you made me think about it a little harder than I initially thought. And I realized that, you know, in this language, you don't actually have to choose if you want automatic dereferences or not. I mean, you don't have to be forced in one way of thinking. I mean, you can literally choose if you want automatic dereferences or not. In my case, I will start with just detecting them. And then we'll see if we could like just ban them or display them or whatever. Thumbnail is very clickbaity. Nice. That's what you want to see. Cool. Next, let me also get the procedure header for the block. Proc header is body.header, right? And if proc header name not equals to main, we will just like here continue. Easy clap. Let's do that. Okay, nice. And here print vars, and let's do statement. Okay, we have a few statements. We have a declaration. Let's open the main here on the side. It's ptr.js. So we have a declaration. Here's the declaration x. Then we have another declaration, which is this px pointer to x. Then we have even more declaration. So t is a declaration. Cool. Then we have a binary operator. So equals, right? Binary operator. Another binary operator, and then procedure call for print. Let me actually remove the print because I don't really need that. Let me also put the comment here. Right, okay, and we have a binary operator. I'm kind of actually this is actually interesting that we don't get like an like, you know, assignment or anything, just straight up binary operator. So it means that we need to recurse down into the binary operators to see if it's an equal sign. So do we not have a high level so do we not have like a high level thing for assignment? We have assignments. Oh, we have it for comma separated arguments, right? Yeah, so I guess we need to do this. You need to recurse into the operator type and see if it was an assignment operators aside from equals. What's that? Oh, operator type. So it's probably is equal, is not equal. So are those operators that are not just single character, and all other operators are just, you know, number by the character? If op equals to interesting. Let's assign something LLVM. Yeah, so there's no separate stuff for it. What do we have here? A binary operator. So binary operator. This is the code node, binary operator. Yeah, code binary operator. There you go. Right. So if statement dot kind equals to binary operator, then we do op equals to cast code node code binary operator and statement, and then let's print vars this motherfucker. Okay, binary operator allowed by context and some pointers. What do we have here? Operator type. This might be a member of enum operator type, or might be an ASCII value. Yeah, which is out of range of the declared enum values. So yeah, okay. Loose, that's pretty cool. Like loose is a thing on Jai enums that lets you set a values that's, you know, don't really fit into the enum, which it's like a very niche use case, but sometimes they're useful. For example, in X11, like you have enum atoms that are kind of typed, but then atoms might be like whatever number. So, you know, the enum has to be loose. Niche use case, but I guess sometimes it's useful. We have also nodes, alignment expression. What the fuck is alignment expression? Declaration properties. Oh wait, this is the wrong one. Yeah. Flags. Left and right. Okay, we can have left and right. What are the flags? This is one like allow. Yeah, these are flags. Node flags. Expression is spread, no array bounds check, allowed by context. What does it mean, allowed by context? Statement is deferred, is parenthesized, no arithmetic created by desugaring. I think this is irrelevant to us. Yeah, I'm pretty sure it's irrelevant to us. So we will be looking into left, right, right, left, right, and operator type. What are those? Yeah, it's like left, right. And 61 is the character code for equals, I assume, right? How do we verify it? Let me quickly see. ASCII codes. Yeah, ASCII table. Let me check real quick. And 61 is, yeah, 61 is equals. Yeah. All right. Man. Oh no, I'm in Python. I'm sorry. Holy shit. Look at this. 61, yeah. I didn't know that there's a manual on ASCII. Cool. Okay, so if op dot. Isn't it funny that we are using automatic dereferencing in the code that should detect automatic dereferences? Equals this, then print vars. Let's check the op.left dot star and op.right dot star. Let me actually do that so it prints on the side. Look at this. So left is How is left a binary operator? Oh, binary operator like is as a star, right? So that is a binary operator. and right one is a cast. So seems like cast will tell us if it's a reference or dereference, right? So let me just explore it further. If op.write kind equals cast, then our cast, I'll just like cast underscore equals to cast op.write to code cast, I guess, and print vars. Let's explore that. So we have a cast of a cast is implicit is pointer dereference. Huh. There you go. We found it. Right. So we have our main binary operator. Right. We have a left and right side. Right side of the binary operator is a cast. And the type of this cast is implicit and the pointer dereference, right? And so it means that we want to detect that. So this is what we want to detect. And in the other case, it's unary operator. In the second case, unary operator. Whatever it is, let me check what I wrote there. Here. Right, so here's an implicit cast with a dereference, and here is a unary operator. So explicit dereference is a unary operator. But I wonder why this is a binary operator, dot. But dot star is a unary operator. Oh! Because this dot has a left side and a right side, right? So left side is a struct, right side is a struct, left side is a struct, and right side is a struct field, right? But this is unary operator because that's how it reads. So it's not like a star, it's star dot, which is an operator, right? Star dot star. Is there nothing like that? Dot and star. Yeah, there you go, the reference. Pointer, yeah, is a unary operator. Okay, you see, I was right. I just looked at the output of a metaprogram and I got a right intuition for it. Which I guess makes sense considering that I'm programming in this language for like two years already. You would expect someone to have an intuition for something that you're doing for 2 years, even on a side, you know. I don't program Jai full time for 2 years, but still. And we also have it as a postfix operator. Oh, I think it is a postfix dereference in case if it has something after that, right? Just let me just verify it. If, for example, we do this and dot a, I don't know. I think it's just, yeah, it's not gonna type check. So we have a, and maybe a will also have a, which is like a int or something. Type mismatch, type, let me do like b int and b semicolon. Yeah, unary operator and binary. Yeah, it's like a binary operator, and I bet that it would be like a postfix, blah blah blah. You think so? But I got a unary operator here, even though I didn't use it like this. You see, I use it like that and it got detected as a unary operator. So yeah. Anyway, the point being is that we got our fucking implicit is pointer dereference. Yeah. If kind equal cast, and then what do we do? Code cast. Target, we don't care about the target. Expression, code flags, cast flags. Okay. If cast dot cast flags and dot is implicit, I think I can just do this, right? Is pointer dereference, like print like, how do we phrase it? Found implicit dereference on, and here we should like print location. There was something like print. Wasn't there something for printing location? Code location. Source code location. Assertion handler. Print assert. Is it? I don't know, it just like raw dogs them. Just literally raw dog this motherfucker. Right. Yeah. Yeah, so what do you have? We have this. And where is on the code node location? Kind location. Okay. Yeah, literally just location. Oh, wait, what? It's not a code location, it's just literally location. Index of the starting line. C0 index of the starting character in bytes. So it's start end. What is, yeah, it's like start and end. Yeah, it makes sense, right? Because code node has a range of location. It's not literally just a single location. Yeah, that makes sense. That totally makes sense to me. Is there anything that just kind of accepts that? Is there like something that we can print it with? No, not really. Do we have a file name on message type checked? Message type checked has a message, and message has a word. Fuck. Do we have like a file or what? Oh, do I need to listen to message file? Yikes. Can I maybe... let's add message files so I can maybe print it. Message is file, like case.file. Oh, bruh. Message file mf equals to cast message file message. And what do I want to print? Let's just print it. We have a fully path file name. And I guess that's it. MF, like motherfucker. Fully path file name. And I guess we can also have it as a string in case it's a build string or something. That's okay. Let's see. Where do I miss the semicolon? Oh yeah, it's. Wait, what? Incorrect number of arguments. All right, yeah. Just whatever. Okay, yeah. So we have file. Oh. So you don't have them in turn, right? You have a bunch of files, and then you have then you get procedure bodies. Then you get more files. Source code location has a file, no. Yeah, code location has, but that's not code, right? That is not a code, unfortunately. Or I guess rather code node doesn't have it. And seems like message file doesn't give us those in turn. Yeah. What else was there? There's like message import. Message phase. All source code parse, tape checked all we can, target code build, pre-write executable, blah, blah, blah. This doesn't look useful. There is like polymorph report, which has source code location. Actually, interesting that polymorph has it, but code node has like a regular location. Oh shit! I look right at it and I don't see it. It's literally here, message file, and it has a file name. Okay. Bro, I mean, I hope someone in the chat caught it. File equals, what do you have? Cast dot and closing load. Right, and we need to print file dot fully path file name. Let's see what it's gonna be. Found implicit dereference. Yeah. Dereferenced in, and then do like line and a column. So file path name, and then cast dot location dot L0 and cast dot location dot C0. And yeah, found implicit reference in blah 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 1411, right here. Whoa, what? 1411. Yeah, here literally points us at the right where we want it to be. Yeah, this should be detected and reported, and we detected and reported it. Nice, that's a very easy W. It took only like 40 minutes and I almost was productive almost throughout. So what other cases we have for implicit dereferences? So I need to use code visit because let me like not print that. So I only have let me just remove all the print vars. Yeah, we do that. And found implicit dereference. Yeah, here. Coolio. Yeah, procedure arguments. And maybe default initializers for structs, right? The ones that are in declarative scope. But maybe they're reported through procedure bodies of, initializer of. So we'll see that. So we have like a test procedure, which, for example, might take A of type A, or maybe like test. Right, and let's say if you want to like call test with a pointer to something, right, like px, or no, like pt equals to pointer to t, right, and we just call pt here, and we compile. So this is gonna be implicitly dereferenced into this, like, right? Like t is, can I, thank you. Here t is 0, 0. Why is it 0? It's px. Ah, yeah, because it's like literally all. Yeah, let me do something like, so I got the pointer. Oh. Px dot a equals 5. This is also an automatic dereference, right? Because explicit one would be this, right? So this should be detected. So dereference, but on the left side, also should be detected. This should be detected. This should be detected. This should be fine. This should be detected. Do I detect it on the call side or on the receiving end? No, of course on the call side. What am I talking about? Yeah, feeling productive. This is also a binary operator, I'm pretty sure. Right, and let's print left side and the right side. Literal binary operator cast found. Oh, binary operator and literal. You have binary operator and literal. Oh, wait a second. So this one is binary operator. So I need to visit that as well. Ooh. So, and I mean, right side can be arbitrary nested, but I think, so like this can be detected, right? But I'm pretty sure if I have like an arbitrary nested kind of implicit dereference, then the top level will still be a cast, right? No matter how complicated this part of the equation is, if the resulting type is a pointer and it is dereferenced, then the kind of overall type here will be implicit cast. So this should be fine no matter how hard it is. This, on the other hand, though, this should be somehow well, can I actually do something like, maybe like, let's do a equals like 5, right? Pointer to a equals pointer to a. Can I do pa equals 5? Can I do this? Okay, that's actually impossible, right? So it doesn't really work on primitives. So it doesn't let me assign a primitive literally to a pointer. So the automatic dereferencing isn't always working. So this will require me to dereference explicitly. So it doesn't let you go like all the way. I guess it only looks into like structs or whatnot. Yeah, what if I do strings instead? Right? What if it's like hi? And here's the pointer, and I do this by also. Oh. Yeah, so it doesn't let me do that. But will it let me do that on the data? If I do hey Vivian, I mean, yeah, all modern languages, I think all modern languages have automatic dereferencing, right? Does actually Zig have automatic dereferencing? I mean, Zig is quite anal usually, but automatic dereferencing is such a modern meta that I wouldn't be surprised if it has it. Let me check real quick. Zig dereferencing. Language reference. Dereference. I mean, yeah, there is a pointer dereference, but I don't know how to check it quickly. Does Zig have automatic dereferencing? When accessing a field through pointer to struct, the use... okay, it's optional. Okay. Yeah. And there's a... Okay. There's a langgraph which has, when using a pointer to a struct, fields can be accessed directly without explicitly dereferencing the pointer. Okay, fields can be accessed directly. But can they be assigned to directly? That's a completely different point. Anyway, I'm not gonna like go on the documentation bender. I was just curious. So this doesn't work, right? It literally doesn't let you do that. But will it let me do that on the data pointer? Right? So for example, we have a pointer to the string. And I can do this, like 5. And this is just fine, right? It lets me do that. But it's the same as here. And I guess it will let me do the same with the data pointer too. So, right, data actually accepts the pointer, so it doesn't make sense. Yeah, I guess it's... yeah, I guess it's the same. So this should be detected. Let's work on that one. In this case, what do we have here on the left? We have a binary operator. 2, again, binary operator. So here we're checking right one. Let's do if op.left.kind equals to binary operator. Then let me again print recursing into left. So we have binary operator, we have right as literal, recursing into left. Left one is another binary operator. And right is literal. What? Oh, I'm an idiot. We need to left op equals to cast. Yeah. I need to code binary operator and op dot left. Yeah. And now I need to access these on left op. Yeah, like that. So recursing into left. We have left op left is identifier. And right is also an identifier. So there's like two identifiers. Oh shit. That's actually interesting. So both of them are identifiers, and how do I detect that it's like a dereference or something? It doesn't say cast here. Am I even looking on the correct one? PTR. Yeah, this we don't do. We do the binary operator. And here's the literal. Yeah, operator, literal, and 17, line 17, right? This is line 17. Yeah, it is a line 17. Okay. So we're looking at the right thing. And left one of the left side is identifier, and the right is identifier. Okay. So left is gonna be left op dot left, and right is gonna be left op dot right. I think I'm gonna be super confused about all these lefts, rights at some point. And if left dot kind equals to ident, let's do ident left equals to cast to code ident and left, and let's print varset ident left. What is it gonna be? Recursing to left, ident. Oh, I need to dereference it. Woo. Recursing to left, ident left is identifier px. So this is the name of one identifier. Wait, what? Oh yeah, correct. It is a px. Yeah, you're right. And right. Oh shit. Is this it? Oh wait, no. When we print in too much, I get confused in the print, but yeah. So we have left identifier is px, which means that the right one will just be called a. So this doesn't give me anything. Oh wait, I need to get the type of the operator here. So if left is a binary operator, I need to print that. So let me print varset, and it's gonna be left op dot. Yeah, I want to check its type. So we're recursing. Left op is a code binary operator of 46. I mean 46 is a dot. Right, so we'll do the cheat code and 46, yeah, you see? Code 46 is a dot. So yeah, there you go. It's an operator dot. That's, we can actually check if it's a dot. Right, and if left kind ident, if right that kind equals ident, we do the same. So far I'm writing like a really explicit code, but when we are kind of done with exploring, we can actually compress it with code visit. Ooh, and write some kind of a generic, you know, generic traversal where we just do this thing in a more generic way, so we don't like check for all of that. Or maybe the checking logic will be preserved, will just recurse. We'll see how it goes. Right ident recursion left op, ident left, ident right, px what? Oh, it's right, should be right. Yes, tool, it is. Ident right is a. Oh, look at this. Code identifier is right hand side of dot dereference. Fuck yeah. Man, I mean, it feels like John literally, you know, predicted those use cases. Like, you literally get all the information you need. You know, on I can't remember like a situation where it was impossible to get the info I need from the metaprogram. I mean, there is stuff like when you get compile errors, there is no way to programmatically see what exact error was, right? So, but when you get type checked events, you literally have everything. Cool. So we have left, we have right is RHS of dot dereference. Yeah, enforce house rules. That's what we're doing. We're not necessarily enforcing house rules, but we want to at least know what's going on. This keyboard has forsaken me. Yeah. So if I get dots, I need literally to recurse into dots. Is RHS of dot dereference. Compiler is RHS here. So on identifier we have this. What do we have? We have defines polymorph variable of dot of an identifier is RHS is right hand side of dot dereference. Resolves shallowly, generated by operator overload, do not resolve due to parser. Can resolve to rec, has scope modifier. Scope modifier. Scope modifier is like this. Right, this is a scope modifier. Yeah, so we need that. I wonder if it's used anywhere in the standard distribution. No, it's literally not used anywhere in the in the language distribution itself. I wonder if, you know, Thekla game, the Sokobon game uses it. So yeah, we need to check that. I guess if we get a dot, so we have stuff. If on the left we have a dot, we need to gradually recurse into it until we find this right-hand side of dot dereference. And I also wonder if you get this identifier like right-hand side on dot dereference, if you dereference explicitly, we will need to add that use case, right? So we get right hand ident right, and if ident right that flags and is RHS of dot dereference, then we also need to print that. Right, and file is equals to ident right that in closing load and file and cn equals ident. right, and let's do that. CA, and CN is like code node. And let's do the same here. It's just so when I extract it, it's easier to me. Boom. Recursion to left, found implicit dereference on line 17 and found implicit dereference on line 20. Oh, we actually checked twice. Ah, yeah, we check. Oh, wow. So why do you print line 20 twice though? Up left, up right, recursion to left, left up, indent left, found implicit dereference. Bam. Oh shit. So does it mean that let me print ident right. Right, so where is our line 17? Here we found implicit dereference on the line 17. Then we get the second one, binary operator, recursion into left, identifier left is called ident, and identifier right is A, is RHS of dot dereference 2. Oh, so we don't even have to check for the cast. Look at that. We don't even have to check for the cast. So these two are literally the same case. We don't even have to check if this is like a... But why? Wait. Why would this be a right-hand side of dot dereference? T is not even a pointer. Is RHS of dot dereference. Why would this one be RHS of dot dereference? Wait, am I missing something? T.A. T.A is this. Let me rename it slightly. A int, AA, like test A, test B. Let me just slightly rename them. So PX is pointer to X, like A is A, PA is pointer to A, then we do PA int equals 5. Then we do T is test, T dot test A equals pointer to A. And then T dot test A equals pointer to A dot dereference, and T dot test B equals to pointer to A dot dereference dot A. And pointer to T, and this should be detected. This we don't do yet. Let's compile, and A that struct A is not a member of A. What? The fuck? Ah, this is A int. Cool. So it's just like easier to see what's going on. YouTube rewinding is legendary. Yeah. Watching streams on YouTube is definitely has better quality of life because of rewind. but yeah, chat is worse. So there's no like 7TV, BTTV, you know, the general like people like white people happy spam. So here, test A. Yeah, it says that test A is RHS of dot dereference. That's like really weird. Let's go back here. Again, we see up, left, right, unary operator. Left is a binary operator, recursive into left. Yeah, left is T, right is test A, and also RHS of dot dereference. Huh. So you see, it thinks that 22 is a dereference, which is not. Is right hand side of dot dereference. Oh shit. So maybe is RHS of dot dereference just generally means that, okay, this is the right hand side of a dot operator. So like, okay, this is a field of a struct. Maybe it doesn't literally mean dereference. It's just like, okay, this is dot field on the struct. Huh. Fuck. Right. Right, so this, like, is RHS of dot dereference doesn't literally mean that it's a dereference of, that this is a dereference. Because in this case, where is it, 22? Yeah. In this case, test A is not a dereference. Like, it just says that, okay, this, like, if you're a dot, if you're a dot after a struct, then it is a dereference. Either it's just, you know, like a name that's not very descriptive, or it's like a bug that it thinks that everything is a dereference. So this is kind of, we need to verify that. Right, so YouTube has better global emotes though. Oh, are those global emotes? You can't even select them. Wait. Actually, I can. Tool face, purple, crying face, blue, smiling cat, orange, whistling. Yeah. Like, I can't hover over emote and see its name. I think colon emote name colon is not a Twitch feature, is like FFZ feature. Right? I don't think it's built into Twitch. It's one of the Twitch chat extensions. Yeah. Okay, I'll take a small bathroom break, and then I will see how do we check out that this is a dereference. Everything via browser extensions, true. Yeah, I'll be right back. You know, I want to stand up. that's right. Now it's a stand-up comedy stream. Okay, that didn't take too long. Yeah, sorry. So how do we distinguish a regular dot access from pointer dot access? Let me think. Before I do, is there any questions about what we're doing? Serious on topic questions? Yeah, let me know. Let me know in the comments below. 7TV used to lag my Firefox so hard it would lock up. Holy shit. That's not good. It never happened to me. Have code ident. Maybe if we recurse it to code identifier, we can see if it's a pointer dereference. Compiler code ident. We have a resolved declaration. So let's do dot declaration dot star like this. Result declaration is a call declaration. Type instantiation, expression, alignment. I don't know. Oh. Have a call declaration. Type inst. This is a. So this is a type. Oh. Can we? Can we? Type inst is null on it. But we have an expression. So we have B. And B is just literally a code node. It has a bunch of flags. What are flags? Is constant, blah, blah, blah. Scope is global, has code modifier. Alignment expression, nodes, program export name. It doesn't have flags, doesn't have anything. So it only has expression. It also has entry. What the fuck is entry? Oh, code scope entry. Yeah. So this is kind of useless code scope entry. I mean, for us. Ooh, let's read its expression. Just like keep dereferencing until we do something. That expression, unary operator. Huh. Unary operator. Interesting. So we'll find. I wonder if this unary operator is a dereference. Expression is a code node, right? So unary code unary operator. It has what? Operator type and sub-expression. So if it is an operator type, I wonder what it would be. So let's do that. Exper is this, right? Expression. Now if expr, so if it's not null, we will just print that motherfucker. Now if expr that kind equals to unary operator, smooth operator, okay, UO equals to cast to code unary operator expr, and then let's print vars, that motherfucker. What does it give us? UO.star unary operator of 42. What is 42? 42. Oh shit, it's a star. Look at that. Isn't it poggers? It's literally a star. Wait a second. Does it mean that we actually can dereference it? So we have left operator, which is a dot. On the left side of it, we have an identifier, right? Let me ident left. Let me just print. Let's do this like ident left is ident left dot name. Ident left is PA, and then unary operator on the expression is a fucking dot, right? And if we go here, then PA, you see, no, not a dot, a star. You see, PA actually doesn't have any fucking stars. Do you have any other unary operators there? We have unary operator on the right. Ident left T. Okay, ident left T. Yeah, so this is actually incorrect. We can't claim. We literally cannot claim if the right side is RHS of dot dereference that it is an actual dereference. I think this name just signifies that we are accessing a field of a struct. So let's comment that path out so it doesn't confuse us. And so PA star, right? So it's like kind of PA star, a int, yep. And then binary and literal. So this is that. Then we need this. So wait, no, not this. We have OP left, OP right cast. Yeah, this is our actual dereference that we detect through the cast. We recurse left. There is no like unary. Yeah, there's nothing unary about it, right? Identifier left is T. Yeah, and it is an identifier, but we don't go into it because it probably doesn't have an expression, right? If expression, else, let's do that. Print no expression on ident left that name. On left ident. No expression on left identity, right? But the right side is where is it? Yeah, but the ident right is a cast that we detect correctly as a dereference. And the next one is another dot T. Let me also print right one. Ident right, we do this. Ident right is ident right that name. So it's just like less confusion. Maybe actually let me somehow, like, I don't know. Instead of printing a statement, I want to just, you know, break those apart. Something like that. Oh, fuck. Empty statements. Let me put it here. Yeah. So this is one. This is the second one. This is the third one and fourth one. That's much easier. Much easier. So the second one is op left. So left is T, right test A, T dot test A. And if we open our file, oh, PTR, if we open that file, yeah, T dot test A. Yeah, T dot test A, and the right one is a cast. Cool. Yeah, we recursed into left, and we did not detect that it's anything like suspicious. Yeah, it's not like a, and it doesn't have any expression. Yeah, so I guess that's where it holds a dereference. It holds it on an expression, because here, in the first case here, like pa.aint, yeah, we have pa.aint. Between those, there's a unary operator, which is 42, and 42 is a star. So if we open man ASCII, can I search like quote star quote? No, I can search. I can't. Oh, yeah, here it is star. Yeah, 42 is a star. So that's how we detect a dereference. But you know what? Can I detect if it's implicit or explicit? That's actually an interesting one. Right. Yeah, you can use forward slash and control N. I just was wondering if the characters are enclosed into quotes, and they're not. Let's look at this one. Oh wait. Well, first let's look at this one. So pa.star .aint equals 6. So this should not be detected, right? And if I launch it, the first one has a unary operator, and the second one has a... Oh shit. Left op is binary operator. Look at that. It is a binary operator. So this is a binary operator, and it doesn't get detected as a... yeah, it doesn't detect it as a unary. It's a binary star. That's cool. Yeah, so this doesn't have, this is an implicit, this is an explicit. I just wanted to check if they are any different in the messages, and they are. So the explicit one, it has a binary operator. Here. Wait, it's a dot. Right indent is a int here. And indent left, there is no identifier left. Yeah, okay, there is no identifier left because the left one is literally another dot, right? So because left one is this one, is a dot. Yeah. But both of them are dots, so have left binary, right literal. Same, left binary, right literal. We recursion into left, and we found in a dot here. We print an ident left, and then we find in a unary operator. Here's 1, 2, 3. Oh, but the left. No, left is also binary operator. But we we're just not finding it. So it's the same kind of, here's a dot and here's a dot. But here we're not recursing. Wait, why are we not recursing? Yeah, left is a recursing into left. Here we go. Left up, left right. Ah, if it's an, because it is not an identifier, because the left side is a star, right? If an ident, let's do else. Left is not dent. And just like left, I guess that's star. What would it be? Left is not ident is a unary. Oh fuck, it is a unary operator. So we will be having a unary operator that is not an identifier. Right, so look at the difference. The difference is that in the case of an implicit dereference, we have right-hand side and left-hand side of a dot. Both of them are identifiers. And we get unary star only when we look up an expression on the identifier. So we go identifier.expression, and expression has a unary operator. Okay? And in this case, we look at left side and the right side is an identifier, so the same as here, but the left side is not an identifier. Left side is a unary operator, like railway. Yeah, it's a unary operator. Unary operator. And it's not even. So file, location, and look at the code of a unary operator. What the fuck is this? It's literally different. Right? Oh no, because it's a code node. Let me cast it so that I can see what exactly it does. So else else if left.kind equals unary operator. Let me do this. UO right equals to, where do we cast it? Like here. Right, left is not an ident. UO left. How do we do? I can do this. Left. I can just do this again and cast it. Wait, what? Oh, it's left equals. Oh, I can't reuse left, or can I? I don't think it. Yeah, because I'm using the thing inside of its own declaration, right? So let me just do this. So we get left is not an identifier, left is a unary operator of the code 169. So it's not just a star. 169 is actually something completely different. It's probably dot star. Where do we have it in the compiler? 169. Yeah, postfix dot star operator. Cool. So postfix dot star is an explicit dereference, but regular unary star is an implicit. Like this. Yeah, 42. Like this kind of makes sense. But it's also, you know, it would be more kind of safe just for me if this information was a bit more structured. Because now I have to look, like, this is an explicit one, right? This is an explicitly typed out unary.star. If we go here, ptr.jai, yeah, it detects this as a unary operator. Like, this is what it shows me on the left. Right, so whatever is on the left was explicitly dereferenced. So this is fine. And I mean, technically we need to, you know, go further because, okay, this was explicitly dereferenced, but what if something previously was implicitly dereferenced? Because this can be, you know, arbitrary kind of nested, right? And one of these might be dereferenced implicitly. So technically we need to go as further left as we want before we hit like the first one, right? So this is where you would use like code visit and whatnot. But for the simplicity's sake, for now, the way we tell one from the other is by looking at either explicit.star or on implicit star that is here. Oh, or sorry, that is here. Yeah. Which is kind of sketchy because since instead of telling that, yeah, this is a dereference, it just tells me there is like a unary operator of a star. It kind of tells me that, you know, what if this is like just an implementation detail that's gonna be changed. So yeah, I think I'm like gonna email John and ask them if, you know, he maybe can, instead of doing this, just say that like left side is an implicit dereference or something. But for now, let's go with the flow. And where's our build metaprogram? If ident, if left side is unary operator, right? And if UO dot unary operator, was it called? Operator type, yeah. Operator type equals star. Regular singular star means implicit dereference. In case of an explicit dereference, we would be getting operator type 169 unary dot star. Right. If this, then we actually, I guess, report that motherfucker. And we report what? What? What did we report here? Cast. And in this case, we report the part that is unary operator. Yeah, so I guess we do like UO. S32 type given string. Oh yeah, you're right, because it's a char. Okay, so found implicit import, line 15, 11. Okay, let's check it out. PTR 15, 11. Wait, what? The fuck? Is this the wrong one? Oh, I was seeing this star. So okay, it was explicit. I completely missed the lines. I should have looked at the lines. Fuck me. This line is 17. Damn. Okay, so this... Wait, what? Yeah, okay. So this is like all wrong. This is a unary operator that is this star. Ah, I started getting it because it is a binary operator. Okay. Yeah. Fuck. So what are we getting here? Or do we? Left is PA. Right is A int. No. Wait, no. It is correct. It is correct, but why is it line 15? What? 1511. Why does it report? So it's correct, like A int, right? Indent right. But A int is here. 17. Oh shit. Look at this. So it, yeah. So this is not good. It gives the information, but it's not good. Look at this. I was right. So we get the operator, which is on the line 17. This is the line. This is a column, right? So we get those on the line 17. But when we recurse, we get the unary operator dot, which detects itself on line 15, right? So this is what it shows me. You see? So you get an unary operator on this line that refers to this star. So it somehow like attaches a dereference like here. That's not good, man. That's like not good at all. Like it gives me the info, but it's kind of like backwards. So yeah, we need to add something here, which means I will have to figure out a way to like explain the issue nicely, right? Because like John wouldn't have like all the context we have here, and you won't make him watch 2-hour-long stream. Anyway, yeah, we'll figure something out. So instead of reporting line 15, we need to report it on the... I mean, I guess we can report it on the right side. Right, so... like PA is the one that's getting implicitly dereferenced. So we do identifier. Yeah, identifier is getting implicitly dereferenced. Right? Yeah. That's what we report. Left, it's left ident. It's ident left. Yes, so ident left. Oh. Right? Yeah, ident left. And now it's going to be reported correctly. Yeah, we have a implicit dereference here. 17, line 17, 5. Yeah, okay, so yeah. This is correct. This is dereferenced implicitly. Nice. And the second one should still work, right? 21? Is it line 21? Yeah, line 21, column 16. Yeah, okay, this one gets... Right, okay. This is all working now, which is beautiful. Next case that we should detect is calling the function with a parameter that automatically dereference. I'm not gonna lie, like metaprogramming kind of melts my brain a little bit. I already feel cooked. I feel like I need a break. Just like a brain break. Criticusi. I look like a Lego character. Why? Am I blurred? No, I'm not. Why am I looking like a Lego character? Is it because my t-shirt is yellow or what? Headphones and shirt, I see. Metaprogramming looks annoying to learn. It depends on the type of metaprogramming. Like metaprogram, it can be super verbose, but I mean, you have an actual debugger for metaprogram, like bytecode debugger. It looks kind of like command line GDB, so you can use that. It also has limitations, but you know, if you're stuck, you can use typing debugger. Printing this is actually quite convenient to me, and we can actually take it to the next level if you want. So if every time I call print vars, I wrap the target function into format struct, right, and pass a couple magic parameters. You can even get where are they? Or was it like, oh, not name, sorry, because this is not a struct. Where do we print vars? Yeah, if you do format struct here, right, into one true, you can format structs like this, right, and you get actually like, you know, kind equals this, not flags this, so you can do that if you want. Which gives you way better representation. You can step debug into metaprogram as well, if you're super stuck. And you gotta realize that the way I write it now is very explicit, specifically because I want to kind of hand code every case that I'm testing so that later I can collapse them. So in reality, I won't have to do this. Right, left kind, like I'm not gonna have this in the end. So what we're gonna be using in the end is called code visit. Let me find it. Code visit, and code visit is a set of user space tools that can give us sub-expressions of a code node. So instead of doing this manually, I can just call a code node and I get sub-expressions, and I can just check them in a flat if else, or even better, there's like, I can recurse into the node breadth first or depth first. So you can imagine passing a code node here that is a binary operator, and then you would just gradually recurse like back into its like left and right hand side, as long as you get binary operators, and you can check which of them is implicitly dereferencing. Yeah, so you have a library helpers to make it nicer, right? But for now, I just want to type it all out, just so I see how the code path looks, so that by the time I call these helpers, I already understand the kind of the space of a problem. But still, yeah, you know, kind of programmatically navigating abstract syntax tree is definitely verbose. That's for sure. That's why you have stuff like compiler get nodes that you can use for an actual macro. That's also why you can get code by just concatenating strings and insert them. There are few high-level ways to construct and navigate code, but in the metaprogram, you kind of have to do this even with helpers. Right, but you have also stuff like get value, right? You can just... What else? Pre and post order. Yeah. There's a bunch of stuff. You can imagine more helpers, right? Get identifier name, right? Things that would like check if identifier is not null and return your name, or you can get stuff like, hey, here's procedure header, return me all like names of the arguments. You know, you can imagine a bunch of kind of high level helpers that's just not been implemented because I guess nobody really either like mailed them in or asked for them explicitly. Yeah, but these two, like get the recursive nodes, are very cool. I use them in my or return macro to a great success. It's actually very simple to learn it. It's just very kind of verbose, right? Because you have to deal with that each individual abstract syntax tree node. So yeah, like I get your point, even though I don't necessarily agree with it. Even as someone who does 9% language dev as a hobby, learning how to traverse someone else's AST seems complicated and annoying, just like XML library or whatever. That's a nice comparison with XML. I can see that. I can see the comparison. Yeah. I can also like have a helper here. So for example, let me do that. Like I have a PV, right? And it's gonna be something that accepts like S of, I don't know, like T. Where is it? Like T. And I think it can call it print vars, right? And this would be also like kind of like a pointer to T, I guess. Do you have, I think this is what you do. And you can do, it will be less convenient because you're not actually seeing the name of the thing, right? So I'm not gonna do any helpers because they will obfuscate the name of an identifier. But yeah, just an example, you can format struct in a nice way. I just don't do it because at this point I did enough metaprogramming that I kind of can eyeball the position of arguments, can kind of see what they are. But we can do that, right? If I, let me do like print vars. Where do we actually use it? Right here. Format struct, right, and wait, not one, true. So one means, just to explain it, format struct formats your struct in a way where true means print a longer form with like line breaks, and one is how minimum fields the struct should have to print it in a long form. So yeah, this basically means print the long form of a struct always. And if I do that, yeah, you can see that we have an operator left, operator left, operator right and left, and you can, maybe for the viewers that is easier to do, to see the difference. I don't know. Let me know if this is kind of more convenient to look at. Ooh, print vars. Where else? Yeah. Let me know in the comments below. Yeah. Definitely easier. Okay, yeah. I should have done that right away. That should be default. For print vars maybe, and I think print vars could maybe automatically dereference the inner pointers too, right? So you can, you know, have this as deep as you want. You see how automatic dereferencing is actually useful, Leonte? Instead of looking at the pointer here, we could use the entire message. We could see an entire message. Yeah. Or do you mean like a generic struct printer? The one that that's like the default struct formatter or whatnot? Yeah. Where else? Format. Yeah, this is not formatted. cool. I think that's it, right? Yeah, this is all of them. Cool. Yeah, so we find our dereferences. Nice. Which is a binary operator. And I need to do the inspect the procedure calls as well. Right? Yeah. Format struct a compile time. Is format struct a compile time reflection, or is that done at runtime? As far as I know, it's just like runtime. I think it's runtime. I'm pretty sure format struct just returns you a string. Like this is literally a string. Or oh no, it's this one. Yeah, it's format struct. Yeah. Right. Yeah, so you return the result here. The result, you return it. And I guess the print vars just knows how to work with it. Because it doesn't print like it just prints value, right? And uses the thing correctly. Actually, you know what it does? I mean, under the hood it calls print. I mean, under the hood it calls print and passes the format struct into print. Yeah, that's literally what it does. So under the hood is like regular print that interprets format struct and gets the value out of it and prints it. So yeah. So print vars, it's literally the same as regular print, and you would do this. You would literally, it literally does that, this, and yeah, that's what it does. So these are more or less equivalent. Print vars is just a macro that lets you not type that out. So it literally calls it literally just calls print, but it gets the whatever code is here and prints it into this part of the string. Yeah. So it doesn't do anything crazy. Yeah, it doesn't do anything crazy. It's just so you don't have to write this part, explicitly. Yeah, it's like very simple. It just uses like program printer to print the expression that you pass to it, and then prints an actual expression. Wait a second, I get a message. Okay. Now procedure calls. Right. So operator. If statement kind is a binary operator. Else if kind equals your call. Right. Let's stop printing all of these vars. Right, let's not print that. Yeah, let me remove all of these prints for now, other than detections. Right. Ident left. So remove this print, remove this print, recursing, and remove that. So you have found implicit dereference, blah. Found implicit dereference, blah. Yeah, and we need to find another implicit dereference. Yeah. And here. Procedure call, let's print vars of PC equals to cast to code procedure call statement PC dot, we do format struct. Yeah, there you go. Wait, did I not? Right, I need to do one true. Cool. Procedure call. Where was the name? Oh wait, the name was on the procedure header. So procedure expression, I think result procedure, argument unsorted, arguments sorted. I forgot which of them. Something and null. Yeah, let's inspect that. It's been a while. Code procedure call. So we have the code typed by the user. Okay. The expression after overload resolution and polymorphism resolution. Oh, I can imagine stuff. So what if there is a polymorphic procedure, one of them receives a pointer and another one receives not pointer? I guess the compiler would just complain then that more than one... It will either complain that more than one resolved polymorphs, can be called, so it's ambiguous, or it will just take whatever is not like implicit. Yeah. Maybe. Arguments unsorted code argument. Argument sorted is code node. So I will need to check either this one or that one. Expression and the name. Null if no name given. So I need arguments unsorted probably. Yeah. So args unsorted equals to PC dot arguments unsorted, and args equals to PC arguments sorted. I'll just print both of them. And slide like for args unsorted. We're gonna print it that star, and for args sorted, I'm gonna also print it that star, right? And we're gonna do fucking jump scare every time. Hey Philippe, hello. I need to make this alert slightly quieter. Welcome raiders. Hello. I hope your stream went well. Yeah. Feel free to type today. Yeah, so this is what we're doing today. Today we are trying to detect automatic dereferencing through a metaprogram and report them. Yeah. It was more fun, Jai. Nice. Yeah, welcome everyone. Welcome. Yeah, so before I do that, rollback netcode, that's poggers. poggers. I don't think I understand what rollback netcode for sure, but is it like a stuff you do when one of the clients is like lagging or whatever? So you can compensate for the lag or ping? Is that what rollback netcode usually refers to? Correct me if I'm wrong, because I'm a little bit uneducated in all of that. But yeah, so what we're doing here is we have a program here, and we have a test struct that inside of it holds like another struct called A. And so what Jai lets you do is it lets you take a pointer to the struct, or rather pointer to the struct, and it lets you assign this pointer like directly to the struct that's technically not a pointer. And Jai would, under the hood, turn it into an automatic dereference. So it's basically what every modern language does. And sometimes it's you might be debugging some bug when maybe some invalid access violation or seg fault on Linux, whatever, and you might want to see all of the dereferences that your program does implicitly. So maybe one of them is a root cause, and this metaprogram, it can tell you where you have implicit dereferences with like file and the name and a column and line and a column. So for now, I programmed two different ways of finding it. First one is this, where you do struct dot field, and the struct is a pointer. So technically this happens under the hood, right? You dereference a struct and you take a field and you assign a literal to it. So we detect this case, and then we detect this case where you dereference the right-hand side. So PA is a pointer, it gets dereferenced and assigned here. So this is two ways we can detect right now, and now we're working on detecting where you pass a pointer to the procedure that then gets dereferenced because the procedure itself, accepts an actual struct. This is actually kind of questionable thing to do, because in Jai, when you pass structs, they are passed maybe by referenced anyway. So maybe what I'm doing here is kind of pointless, right? Because it's not like in C, your struct doesn't get dereferenced here. Like technically what you're getting is like a reference to the struct. But I want to see how the code layout looks like in the metaprogram. But yeah, you just always rewind backwards when new input packets arrive, and you re-simulate the game to handle the new inputs, as if your game engine is playing Braid. That's a nice analogy. Okay, that's why it's called rollback. Interesting. Do you save your VODs on Twitch? Do you publish your VODs? Because I might go and check it out after the stream. Nice, yeah. Cool. I'll probably watch it as my pre-bed activity today. Cool. But yeah, that's kind of the gist of today's stream. I just want to write a metaprogram that detects implicit dereferences. And ideally, I want to support chains of an arbitrary depth, right? So if it's A.B.C.D, right? And this one was a pointer that got automatically dereferenced. I want to detect and report that. I don't do it now. For now, I write it in a super manual way, manually recursing, but after I do all the manual work and, have a good understanding of the process in my head, I will condense it down with using code visit, and we'll just traverse the binary operators with code visitor, with the code visit module. Yay. Report those as potential cache miss. Yeah. Instead of writing found implicit dereference, you should do an red ANSI escape code and write something like unexpected indirection, L1 cache violation found, right? And instead of just print, do compiler report so it fails to compile. Data-oriented design principle violation. Please report to your manager to get your severance package. It's you know, if you do like if you do this and you try to type root password too many times incorrectly, yeah, okay, this one is quite nice. It just says sudo 3 incorrect password attempts, but there are some configurations of sudo where 3 incorrect password attempts, this incident will be reported, right? In some configurations it does that, like this incident will be reported. And we need to do that as well. But yeah, that's what we do. Maybe inspecting procedure calls is useless. My PC snitch. Yeah, every time you press compile, you need to unplug your computer from the network so that it doesn't report data-oriented design principle violations. XKCD, what's that? Nice Nori. Yeah. Sudo su password. Yeah, not in sudoers file. This incident will be reported. Ah, it's not one in the sudoers file. Yeah. Okay. Who reads the sudo? Yeah. Exactly. No one. So yeah, maybe I don't really need to inspect procedure calls because they are passed by reference, and it is not technically an implicit dereference, right? Because even how-to says that like you shouldn't worry about passing the struct, right? Where is it? What? Threader that doesn't take a pointer on an expression. Wait, what is it then? I mean, it is literally, this one is not a pointer, this one is, okay. Wait, no, it's the other way. This one is a pointer. Yeah, okay. So we have a code argument with an expression, and we have unsorted arguments with, like, okay, yeah, it's just type and location. Oh, it is a cast. Oh, so we have a cast. That's interesting. Are you dual booting Windows and Linux? Hey, the boys on YouTube. Yes, I do because I program on Windows as well, and when I need to program on Windows, I dual boot Windows. Some people have suggested just programming under, you know, not along, against wine headers, right? And then just cross compile. But I mean, you know, if I program Win32, I would rather get an authentic behavior. You know what I mean? Hey Rizoma, hello. I hope your stream went well today. I was lurking a bit, as you can probably remember, but since I was working, I just like had it on the side while doing some elbow grease. Ah! Fuck. That hurt. Yeah, anyway. So instead of just doing that, we can instead do it that expression that dereferenced. Boom. right? So we have an identifier. And here we have a cast. Identifier. What is this identifier doing? Code ident. It that expression and ident dot star. Let's see what's that. Can resolve to reg. PT. Can resolve to reg. I guess this means can resolve to register. Probably because the struct is small or something. You found a bug. That's poggers. Founding bugs are always very cool. Yeah, so maybe I need to look into args sorted instead, because those are code node instead of arguments. Yeah. XML probably not really, but if I need OpenGL declaration, I'll probably just parse them off stream, because I can, like, it's funny that you're not the first asking me that. I thought it's not something people would want to watch, honestly. It's like struggling through XML code. But maybe I'm wrong. Maybe my viewers are just so special, so they like some XML parsing. Yeah. Anyway, we have an expression, a resolved declaration. What is a resolved declaration? Declaration type, we have an expression. This is scary. That expression. Yeah, unary operator. Okay. This is a unary operator, and I bet this unary operator will be a star. That will refer to line 15. Let's actually verify that. Let's actually verify it. Hey, code dog, hello. So UO cast to code unary operator expr and UO that star. Yes, it is a dot, but it actually doesn't refer to it refers to line 26. 26 is, to this one, yeah. So this behavior is consistent. So the way Jai reports implicit dereference on the left-hand side of something, it just refers it to a dot on whatever previous line it happened. So for example, here, right, we have pa.aint equals 5. Pa here gets implicitly dereferenced because it is a pointer. And the way we know that it is an implicit dereference is because Jai gives us a unary star that it actually takes from here. Because this expression is on the line 27, right? But the unary dot that we get in the argument is from the line 26, so this one, right? And if I move it upwards, like for example, where is PT? Where do we get PT? Like here, right? Yeah, pointer to T. And now you see this unary operator is on the line 21. This is the one. So it gives us implicit dereference with a star that's literally referring to this star. So in this kind of implicit way, Jai tells us where exactly does this pointer come from, right? Which in my case is kind of weird, right? It gives you all the information you want to know. it tells you that this is a pointer that was gotten like here, that you got here. But the way it tells you that is a bit weird. if you ask me, because you kind of have to jump through hoops to see that. So we kind of have two different ways to get a dereference here, to get the pointer here. We see in the ordered arguments, we can go back through the chain of identifiers and find this unary operator. So 42 is its ASCII code. ASCII code is a star. 42 is a star in ASCII. Or we can go through the unordered list of code nodes, and this is a cast. And I'm pretty sure if I get the actual code node, it will tell me that it isn't an implicit dereference. Let's verify that, right? In the arc sorted, we cast this cast to a cast. Code cast. I think that's what it is. It, and then we do cast that dereference. Yeah, you see, it is implicit and pointer dereference. There you go. And if we go to our procedure and we change this to a pointer, then we don't get those anymore, right? I mean, we still get unary star here, but the cast is not implicit anymore. Now it's like no bounds check, truncate, force, vary force. Has postfix syntax, right? So now this is a completely different cast. Actually, I wonder, like, why is this a cast at all? Oh, because it's not a cast anymore, right? So this is not a cast anymore. Now it's just an identifier, right? Vars it. Yeah, because it's not a cast. That star. You see, now it's just an identifier. So this cast is now invalid. It just happens to work because apparently code cast and code identifier have like a similar memory layout. Yeah. So I guess we check for casts, because it's probably easier than do this than doing that. Yeah, this unary operator that we're getting from completely like different line is kind of yeah, I don't really like it that much. Yeah, let's work with the cast instead. So we go through arguments sorted, and then if it that kind equals that cast, then we cast the thing to cast. You got jump scared me again. Oh, hello, Zig gang. Welcome, people. Loris, thanks a lot for the raid. Appreciate it. Welcome. I hope your stream went well. Welcome, people. It was silent on the stream. Actually, I probably don't. It jump scares me, but you don't hear it because, yeah, my desktop doesn't actually capture any audio. So you can type !today in the chat, and you will see what I'm working on. Today I'm detecting automatic dereferencing in a metaprogram, and what I mean by that is, wait a second, let me just type stuff out. Cast, and then let me put it here. Yeah. So what we're doing now is we have this file, right? And Jai as a language lets you automatically dereference stuff in sort of like a ergonomic way, right? So if you have a struct that, for example, accepts another struct, and you initialize it, right? And you like initialize the first struct, you get a pointer to the struct through the star. You can then get stuff from the pointer and just casually assign to it. And under the hood, Jai will do this. It will dereference the pointer and let you do that because, you know, it kind of understands what you want. So that's what's happening under the hood. But sometimes maybe you're like debugging some like gnarly segfault or like access violation, whatever, like on Windows. And maybe you want to see where are all your pointer dereferences are. And looking at the code and seeing implicit ones are kind of hard. And so what we can do is we can write like a meta program, like Jai has crazy ass metaprogramming stuff. And if I run this meta program, it goes through all the abstract syntax tree of my program, and it is able to, you know, detect those, right? Found implicit dereference on this file in this line and column. So 17.5 is here, line 17.5. So yeah, it points us to the identifier that is getting implicitly dereferenced. And then like another case too, right? Line 22.16 and 22.16 is gotta be here. No, it's like here. Yeah. So it knows that t.test accepts a struct, but I'm assigning a pointer here. So under the hood, Jai does this. And we are detecting that it gets implicitly dereferenced, right? And we are reporting that. So that's what I'm working on today. I'm working on a meta program that detects these automatic dereferences. And now, before I got rated, I was working on the detecting when you pass a pointer to a procedure that accepts not a pointer. So it gets automatically dereferenced here, right? So I can detect these cases as well. Maybe your Vulkan app crashes inside the video driver because you accidentally put a struct instead of a pointer to a struct inside the other struct. But that would be would never happen. Yeah, nobody would ever waste 45 minutes of time to, you know, because you implicitly dereferenced something that shouldn't be a pointer. Yeah, that should be a pointer instead. Yeah, that would never happen to anyone. Never, never, never. Yeah, it definitely didn't happen to me yesterday. Yeah, absolutely, absolutely. But yeah, again, like, thanks a lot for the rate, and yeah, people, let me know if you have any questions. But just to point out, Jai only lets you automatically dereference struct fields, so you can't do shit like you know, have an integer, right? Then get a pointer to an integer, and then do stuff like px equal like 8, right? You can't do that. It doesn't let you do this with primitives. It will literally say, wait, it's like equal. It will literally say you mismatching levels of indirection, right? So it doesn't let you do that with primitives. Only with like, how do you say it, like complex types, right? Right? Yeah. I've got to sleep, but good work so far. Yeah, thank you very much. Appreciate it. And good night. Good night. Anyway, so we were in the, where's the focus of my focus mentioned? Yeah. So I was inside of a procedure call, and I was detecting the cast. Yeah, we get a cast, and we need to check cast flags, right? So if cast flags are one of the is implicit and is pointer dereference, right? Then we literally report it the same way as we did here. So far, I'm doing it very manually, very kind of hard-coded way, just so I understand the process. Found implicit dereference on line 28. Let's go. Let's check if that's actually a line 28. It is a line 28 and the column is 10. Yeah. Literally this shit gets implicitly dereferenced when you pass it. And this is very cool because I don't even need to inspect the procedure header. So I was afraid that this is not going to be enough. I would have to like go and check the procedure header and see if it, you know, accepts a pointer or not. But yeah, I guess since in order for this procedure body to be type checked, this needs to get type checked first. I am getting all the information I need by this point. So did you get byte from this dereferencing or not? Are you implementing this meta assertion because of the crash? I mean, I had a crash yesterday that took me 45 minutes to debug because I'm an idiot. So this just, you know, motivated me to explore, you know, doing something like that. I don't actually want to ban implicit dereferences. I'm actually a big fan of implicit dereferences. So yeah, I just kind of want to have a way to report them, right? In this kind of way. Yeah. And I wonder if I can do something like test that accepts t pointer to test. So it becomes polymorphic. Will it prefer this one or this one? I assume since this polymorph is more specific, it just picks one. It should just pick it. Yeah, you see, we didn't detect it, and not t. T is, yeah, we can like dereferenced. Wait. T and t deref is t dot. Yeah, let's do that. Cool. So it just picks the correct polymorph, so I don't need to do anything here. I always hated the arrow in C, but maybe I would hit the problem too without that type check. I wasn't thinking about it before. I mean, me neither. But apparently Ilionte had to deal with this for sure, because he's like literally the only person I know who is against automatic dereferences. I mean, I'm sure there are other people who don't like automatic dereferences. It's just the only one I know personally. Well, personally on the internet. But yeah, this just magically works. That's pretty cool. Right? Let's just do test 2. This should be fine. I found implicit dereference. Hey, Sloren, thank you. We're kind of taking W's. So, and now what I can do is I can try to compress the code path because now it's deeply nested. I can use code visit to like traverse into the binary dots and just go arbitrary left or arbitrary right until I find all of the implicit dereferences. Right, and what I can do about them is instead of reporting them in place, I would just accumulate them into array to report them when we type checked all we can. Yeah, because what can happen is that somebody can inject shit into the program, and we need to keep collecting those. So yeah, so we just report those at the very end. I think so. Does it only do your own code, or if you use you will get swamped. Yeah, that's a very good question. For now, it only does my code because I hard coded it in my metaprogram, right? So here at the very start, I literally said if procedure header name is not main, continue. But you can kind of easily make it configurable, right? You can, for example, maybe have it, right? So it's gonna be like like handle type checked, whatever, that you can like plug into your own message loop, and you can, apart from passing messages, you can just like, oh, check like, I don't know, check only my modules or something like that. Or like check only stuff in this file, right? You can give it a file, maybe you can give it a module or whatever. YOLO. I mean, it's not very robust right now, but we can definitely remove it, right? And let me remove this as well. Let me remove these. Yeah, let me remove that. YOLO. That's what we are able to find right now. We can't find that many because for now we only look at the top level statements, right? We don't recurse into the statements, right? And that is only basic. Yeah, that's only my program uses. But I mean, let's check it out. So we have runtime support, line 56, right? Runtime line 56. S.count equals starting cursor minus cursor. S is string. Starting cursor is cursor. What is cursor? Is starting cursor. So it's this S32 buff count. Why would it be a dereference? That doesn't look a dereference with. That doesn't look like a dereference to me. Right? $56.15. It thinks that starting cursor is dereferenced. Is it? I don't think it is. And since it's on the right side, I think it thinks that it's a cast. And buffer is also, it's like right here in place. Why would it be a cast? I don't know, this is probably, so this is maybe something, I mean, most likely it's something, but because I don't see an issue. Let's debug it. Let's just check, let's just like kind of go over it. If proc header name not equals this, continue. Right, okay, we detect found implicit dereference. And so this is the case where we binary operator and the right side. So we have a binary operator. We get the binary statement. We do this. We get. Let me check if it goes right. Yeah, here. Wait. Unary. So we're here, right? Implicit dereference in, let's just do this, in cast. Is it cast? Yeah, it thinks that it is a cast. That's wild. Rename in hell. I mean, be thankful. You have a static strongly typed language that lets you do that. Imagine if it was like Python or JavaScript, you would be super fucked now. Print vars. cast.star and format struct true. Okay, it is implicit. Oh, because I fucked this up. How do I do only both? Right, it is implicit cast, but how do I wait, what? Is it not correct way to check it? Oh, it checks like either of these, right? How do I check for both? Do I do it like... Do I do it like that? Ah, so that's kind of... So you say this, right? Yeah. So this is what you're saying? So like if I put a parenthesis, it's gonna be this. Yeah, okay. And now if I run, probably a lot of them will not be an issue anymore. No, I mean still a lot, right? We have implicit casts. Let's check implicit casts in a default allocator. Default alligator. Default allocator module 1822 GG. Oh shit, this is a mem set. 16. So memory heaps is implicitly dereferenced. Where do we get it? Here. Oh, it's right, you see? Memory heaps is a pointer. Like it is an array of pointers. Huh. Look at that. It is correct. So memory heaps is an array of pointers. Why not? I mean, memory heaps is an array of pointers. Ah. Yeah, I mean, so, you know, technically it is a dereference, right? Because, is it though? Wait, is it though? Like, it is an array of pointers. So, I mean, yeah, I mean, it is technically, I guess it is a dereference, no? Because it would be... how would it look like? It's like memory heaps would be a... I mean, data is a pointer, yeah, but it thinks that memory heaps got dereferenced. Hey, Hover, hello. No, bug from yesterday is fixed. It was not really a bug, it was me, an idiot. Yeah, so it is a struct with a count with x64, and a data would be a pointer to like heaps, whatnot. It's kind of like that, right? But yeah, why would it be a dereference then? Uh, 1822. Oh, 13, 22. Memory heaps is a pointer to no, wait. Memory heaps is an array of pointers to heap. Does it maybe triggers because like this is a pointer? Like it is not a pointer to an array of heaps. It is an array of pointers to the heap. Right? Yeah, it says that memory heaps is a pointer that gets dereferenced. Maybe it's like does using somewhere, no? What's that? Holy shit. That's a lot of code. Right, memory heaps here. Where's the top? Where's the top? No, it is all on the top level. It just checks on the architecture. Yeah. Huh. Let's see runtime support. Array. It's like the. Is it? Oh, fuck. Where was it? There was like a definition of. Wait, I think it's in preload. It's not in runtime support. It's probably in preload. Yeah, resizable array is in preload. So that's the resizable array. Yeah. Oh, it's a pointer to void. Yeah. Oh, wait. I build. Sorry, it's me being silly because I copy pasted that, right? So I only changed it in one place. Sorry. Yeah. Oof. No implicit casts anymore. Copy paste everyone. Yeah. Because I wrote everything down manually, so yeah. Shit. You see, Jai doesn't even have implicit casts, at least on the top level, right? And for now, I only detect them on the top level and only on one level of dots, so I don't even recurse into code blocks. And this is what I need to do now. So now I need to condense this code. Yeah, it works, you see? It still detects all of the 3 casts in my own program. In ptr.jai. Ptr.jai, yeah. So 21 is the first one. Line 21, yeah, this is the cast. 5, yes, this is correct on 26. 2616. Yeah, this is the correct one. And 3210, like here. Yeah. It works on my own, yeah. Let me go grab some water and I'll continue. Okay, damn, the water is cold. If I lose my voice because I'm drinking cold water and talking a lot, I'm gonna blame Who am I gonna blame? Well, probably God, because definitely not my fault. Anyway. Hey, Reynold. Hello. Welcome. Yeah, code visit, right? So we go to build and we import code visit. And code visit has stuff like recurse depth first and breadth first. Code visit. Yeah. Get recursive nodes breadth first. Which one do we need actually? I wonder which one do we need? So we have a statement. I'd say we want to go, like if we take like a regular kind of statement, like this, for example, we get that. The whole statement is like an assignment. It's not assignment, how is it called? Yeah, it is like an assignment. You first want to go, you want to go depth first, right? You go depth first. Go like check left side. After that, you want to go deep. Okay, if it's a binary operator, you want to go down. Or not? No, you know what? No, you don't really want to go as far down as you can. Or do you? Maybe you won't. Yeah, depth first. Intuitively speaking, depth first sounds better to me. Where was the main? Okay, here. If proc header name not equals main. Let's return that one. We have a statement. Also, I just realized I don't really check the non-declarative scopes, but I think I switched to that after I refactored the code. Excuse me. Let me refresh my memory how I did that for or return build. So I do sub-expressions, which is an array of pointers to the code node, and I get them recursively, and then I can just iterate over those. That sounds good enough to me. Yeah, for sub-expressions. And do I just shift that? Well, I guess I shift that, but I don't need to. So here I am like recursing manually. Let me actually do, you know what? Let me just commit a checkpoint so I can undo if I mess shit up. Right? So let me just add ptr.jai and build.jai and deref detect checkpoint. Yeah, just so I have like a stable reference to undo. Internetove statistiki. Hello. Hello, welcome. Interesting username you have. Right, now that we have a checkpoint, we do this, and I'll just probably continue here. So I'll just like gradually move the logic from here to there. And what do we have even here? So we get an expression, sub-expression. Let me print all of them first. So print vars and format struct, and we go expr.star1 true, so it prints them really deeply. We do that. Wrong warning statement. Yeah, we don't care about that. So let me open the file. So ooh, this is an executable. etr.jai. Let's go. So first we have a declaration. Here, the declaration. Then we have a type instantiation, which is, I think type instantiation is this one, right? Type in inst. In name, this is a, yeah. Yeah, okay. Right, so we have line 18.5, right? Declaration 18.5, then type instantiation 18.8. This is a first statement. Then 19.5, we get another declaration. 19.11, we have unary operator, right? We have a star, so we take a pointer. Hello Aegon, hello, welcome on YouTube. My YouTube is popping off today. Holy shit, I'm finally becoming famous content creator. Yeah, we have. But why Jai over Zeke, Odin, Hair, C3? Well, first, I don't do Hair because Hair is cancelled. And I obviously can't use technologies that are cancelled. It's against the law. Second of all, I really like Jai because of its metaprogramming. I'm not even afraid to admit it, that I am a fucking Lisp addict. And when somebody says metaprogramming, I start fucking drooling all over my guts. Like, you know, I just start drooling and I can't stop. Yes, metaprogramming. Metaprogramming. That's literally me. Yeah. I mean, Zeke has comp time, right? Which is also very cool. But Zeke is, it's kind of on a restrictive end. Why do people use Zeke over Odin and pure C? So, Zeke is way more type safe than pure C. That's why people use Zeke. And for many people that's enough. It's close enough to C. Like syntax of Zig is definitely C-like, so people use it for C, but it's way more type safe. And Zig is quite, like, it's actually quite restrictive. It really wants to be super explicit about stuff like allocations, and about stuff like, you know, operator overloading. It doesn't actually have operator overloading because, you know, you have to be explicit. And you have to... I don't even know if Zig has explicit casts. I don't know, like, don't quote me on that. I haven't looked into Zig in a long time. But yeah, I personally don't really vibe with it because it's quite restrictive. Right, if we like draw a line between like C and Rust, right? When Rust is being like omega anal about everything, and C is just like, you know, go wild, do anything you want. Zig is like, it's like kind of, you know, it goes like towards Rust. It's like a halfway between like C and Rust, maybe slightly towards that direction. And on my, you know, D&D like alignment chart, Jai is like between C and Lisp, right? So it has a strong type guarantees, but it still lets you that wild like metaprogramming stuff. And like Reynold mentioned Neem. Neem, the issue with Neem is that it is a garbage collected language, right? Which makes it not a real programming language and just a toy scripting. I mean, I'm joking, you know. But yeah, I'm really interested in I'm really interested in systems programming. And when I say systems programming, I mean I need to be able to raw dog stuff, you know, manual memory management. So stuff like Go, like Neem, like C#, like Java, they automatically go out of the window for me, which leaves us with, you know, languages like this. And since somebody mentioned Odin, Odin is more like, you know, Go/Pascal type of stuff, right? Like Ginger Bill is very opinionated about not having metaprogramming, right? He's like, I'd rather package compiler as a library and give you like language-based features, right? So Ginger Bill on that kind of side, he's like explicitly against metaprogramming, right? But Jai, no, Jai is like, it is a metaprogramming language. The whole kind of philosophy of John is that instead of adding features to the language, we need to figure out if there is a good way to make them on the user space, right? If our tooling is good enough so users can build, you know, their own linters, their own like macros to do stuff that is not possible to do in other languages unless you modify the language itself. For example, like this stuff, you know, today I'm working on automatically detecting dereferences. Like, where else can you do that? I mean, you can certainly get libclang, right? Which is basically compiler as a library. You can parse your C code base and you can probably get the dereferences. I think so, probably can. But, you know, you need to fucking package clang. You need to... It's not integrated, right? In Jai, literally compiler gives you messages, feeds you messages, and you work with them. So it's all tightly integrated. Diamond Soon, good to know. I was worried Jai was gonna be as anal as Zig. No, it's way more. It lets you do way more than Zig lets you do by default. I mean, in Zig you always also can do stuff, right? You can have pointer math in Zig. You can have all you want. You just have to always be explicitly telling it, right? It's like pointer cast, like a line, pointer recast. It's a bit more wordy if you want to do like weird shit. Yeah. And yeah, I think Andrew Kelly said that that the like primarily like their focus is to be useful for people who read the code, not for people who write the code, right? I'm pretty sure he even said that or even written that. So yeah. I bounced off of Zig so hard when I realized you always have to put that curly brackets in every print. I don't even remember. I vaguely remember Loris saying that, you know, Zig is not optimized for printing. I like vaguely remember something like that, but yeah. Yeah, but I bounced off of Zig because to me it's on the restricting side. I want to be more like, you know, guns blazing. Sounds like cope. I mean, maybe it is. Hey, Bidarov, what makes Jai particularly good for game programming, and why might a web programmer want to avoid this type of language? I mean, web programmers often rely on garbage collection, right? So, and Jai is not a garbage collected language. So that's one of the reasons. Why it's good for game programming? Well, because it is a systems programming language, which gives you full control over stuff. And somebody mentioned template metaprogramming. I don't want to hear about template metaprogramming in this chat. Template metaprogramming. There goes your template metaprogramming. Might one of the best Twitch streamers on God. Sometimes they be typing and I'm like, bro is yapping about? Gotta be imposters from Ohio for real, for real. Only chance they have is mogging a Sigma and stealing their mewing streak. Emo. So true and mewing based. Mewing peeled. Hey Phoenix, you and your filthy macros, true. Based and Sigma peeled. Look at this mewing. I get all the bitches for real, for real. I show them my dereference detector and they'll be dripping. All HRs on LinkedIn are over me. Fuck, I even forgot what I was doing. What I was doing? Oh yeah, I was looking. I was looking at sub expressions. Yeah. 19.5. Hi against Lord. That's an epic past. 19.5. 19. Where is it? Yeah, okay. So unary operator, the dot. 1912. Identifier. Cool. Format expert. Binary operator on line 21. This is the one. Okay, how does it do it? It goes to the left, right? Binary operator. Wait, what? Why does it return twice? Oh, so 5 and no. Why does it return two binary operators? Like what? 21.5 and 17.13. 17. 13. Huh. Why does it return two expressions for a single binary operator? And then gets the literal. Is there like two binary operators technically or what? Yeah, we're going super low level today. We're going to abstract syntax 3 level today. I'm gonna... Yeah, they have different node flags. This is true. Wait, what? Allowed by context. And this one is no. That's a good point. They also have a... different type. Look at that. Yeah, I'll need to inspect that. They also have different type info. Yeah, and one of them like ends at column 17. So this is the entire one. And another one ends at column 13, which is yeah, here. Guys, yes, the first one is equals. The second one is this dot that stems from here to here. But why both of them are... Ah, yeah, one of them... Yes, one of them is this. Another one is this. Because this dot is a binary operator. It's all good. It's all good. Good. I am actually getting very big stonks from the stream because I have at least 2 Twitch Turbo people in my chat. I remember mentioning that I could literally stalk like Slorent popping up in my stream because every time like Slorent came by, I would have like 10 cents in my earnings tab. And now I get more because we have like a Slorent and Ilionte, both of which are turbo. Oh holy shit! This is paid as well, right? The big emote, the Thunderclap. Yeah, it's 30 bits. Holy shit! Thank you for 30 bitcoins. I'm gonna generate all my microservices that can deserialize a ton of JSON. Can I use Jai templates to get the deserialization logic compiled ahead of time? Like, is it worth it? And how hard are Jai templates? So, Jai doesn't have templates, right? If you will generate your ton of JSON ahead of time, then you can just write a normal logic, right? And you can just execute it at compile time. You can do that. Someone posted key value database for Go. This sounds like a normal amount of dependencies. Yeah. So a lot of Google dependencies, like protobuf, Go CMP, Go immutable radix. Yeah, I mean, it's what do you have, like 173 dependencies for a project like how big? I don't know how big the project is, but yeah, it's not even that crazy. It's definitely less dependencies than average Rust project. Slorent is going with the meme. But yeah, if you're like gonna deserialize a bunch of JSON, you can just like run the shit at compile time. I mean, I'm pretty sure some of those dependencies are kind of I mean, yeah, it's not 170, it's just some lines are duplicating, right? They have some dependencies twice in that file. All right, so let me show it on the stream. Right, so we have, like, this line shows up twice because one of those, like, I don't know how Go.sum files are, but yeah, you see, we have that. Oh, another 100 Bitcoin.
Achievement.
Thank you. Low level achievement. I forgot that my BTTS is this like scuffed Slavic accent. Yeah, so this is not even like 170 dependencies, right? So you have like Go protobuf here for some reason with different versions. I have no idea why. And YAML of multiple versions. You see 3, 2, 1, 3 and 2. Maybe they're like certain dependencies just are like circular, so you have to install multiple versions. I don't know. I don't jack shit about Go. I have a project that has like 20-40 top level dependencies and it expands to, yeah. I mean, that's like JavaScript for you. So the terminal I'm using is like a log file. I see. So I have a terminal that is Alacrity, right? And Alacrity is a terminal written in Rust, and it has an obscene amount of dependencies. I remember trying to package it for GNU Geeks, and it was a nightmare. There's also Ghosty TY, and which Ghosty TI, and look at this. Look at how many libraries Ghosty TI links. Yeah, this is all like dependencies that Ghost TTI uses. I mean, it's a lot. I mean, a lot of those are top level, right? These are all excluding. These are all dependencies, including transitive, right? So it uses like GDK, and GDK under the hood uses a lot of crap. Yeah, so most of those are actually GTK dependencies, not really Ghost TTI. But I mean, still, it is a lot of dependencies, right? But still, you can have even more. I think Telegram has even more, right? So it's, how do you count? Is it like LC or is it like LN? No, LN is a symbolic link. It's, is it like WC? Yeah, it's WC. WC minus C even helps me. Wait, no, not minus C. It's minus... Oh, minus L. Thanks, Laurent. Yeah. So it's 93. Thank you. Hey, 1, 2, 3, 4. Hello. Yeah. And if we have Telegram, which Telegram desktop, right? So LDD and holy shit. And we do WC minus L. Minus L, yeah. It's 253, look at that. And this is actually Telegram being packaged by Arch Linux committee. So they literally dynamically compiling everything. I think if you just download vanilla Telegram, I think vanilla Telegram, it just packages its own Qt, it like statically compiles a bunch of stuff. So you will not get like 200, it will just all be compiled inside of the library, inside of the program. So this is also like the way packagers do it. Yeah. Why is it so easy to package an entire browser in your app and it's so hard to statically link? Actually, Telegram is a native application. It's not a browser. It uses Qt. And it doesn't even use like web view for Qt. It's actually like one of the reasons I use Telegram that much. Well, first, because I used it since forever, but yeah, it's actually a very fast native application that doesn't eat a lot of memory, and it's very like smooth, doesn't lag. It's quite, I would say it is a high quality desktop app. Yeah, but let's not even start about static linking. Like, since we're speaking about Zeek has a very massive thing that I actually quite respect. Wait, what? No way, Zeek used to be a static executable. What happened? Is this Arch Linux packagers? Are those... Is this Arch Linux packagers butchered it? Zeek used to be just a static executable. Is this the default now, or is this Arch Linux packagers trolling me? Linking everything dynamically. Yeah, hey Blind Orphan, yeah, look how they massacred. It was a static executable. I mean, I cannot believe Zeek maintainers did that. I actually can't believe that. I am like, unless proven otherwise, I'm gonna blame Arch packagers for that. Like this can't be the default, because you know Andrew Kelly was always super consistent about it, that you know static compilation is the way, and all that. Yeah, let me actually download Zeek. Like we're on a complete tangent right now, but you know, even though I don't use Zeek, I can't like allow this defamation. Where's the Linux x86? Linux x86 start gz. Download. Archive. Oh no. Okay, Zig Linux. Let me extract this motherfucker. I'm just doing it a little bit off screen, but it's not anything significant. Extract. We're extracting it to like just project third party. Yeah, extract. Coolio. So cd projects third party zig blah blah blah. Let's.la. Okay. LDD zig. Yes! There you go. Fucking Rust packagers. This is how it should be. This is how it should be. This is like one of the big advantage of Zig is that it is just a static executable. You can call it C with improved memory management, weird syntax. I don't have dot in my path. No, why would I have dot in my path? I just cd'd into the... Oh, you're asking why it works like that and like that? Why it works as both this? Because it's not a bash, it's fish. Isn't GhostTTI... I mean, so on YouTube, Myriad asks about GhostTTI being built against libadwaita. It's both. It's libadwaita, adwaita, and GDK4. It uses both. Have you heard a good word about... the only thing I've heard about build.zig is that it spreads like a virus. Like people go and try to submit it to a completely like unrelated projects, and it pisses off a lot of people. That's what I heard. Yeah, just add bit.zig to your GitHub, and you will get a lot of money out of bitches. And I see Bidarov asks, это оказывается русский. Если хочешь про меня узнать, напиши мне DM где-нибудь в Дискорде или на Твиче, в Whisper, я тебе отвечу. Да. But yeah. Like, Arch packagers are crazy. Like they just can't stay away. You know, they have to take a nicely packaged static executable and fucking rip it apart, right? To link it against fucking libclang, like system libclang, like fuck you. Just give me my static executables. And yeah, to the original point, it is kind of hard to get static executables these days, and it gets progressively harder. For sure. I mean, if you ask people, they would just say security, right? Because what if you install a package that statically links, I don't know, free type, and then people find a security vulnerability in that free type version? You know, if you dynamically link, you can just update your system free type. And sure, your application will break because of that, because, you know, backwards incompatible changes. But if your application that dynamically links new version of free type breaks, you can't hack it anymore, right? Yeah, you can't use it, but it's unhackable. So security solved. Yeah, and I'm pretty sure back in the day, people didn't really ship static executables. I think they mostly cared about size, not about, not necessarily about security. I think security argument is just kind of, you know, back how do you call it? Like a second thought, afterthought. Yeah. It's same as people say that, oh, Wayland is more secure than X11. Like, no way. It's not like you can just read your fucking inputs without talking to Wayland at all. Like, you know. Yeah. You know, like people in the 70s complained about size, and now you just fucking ship a Docker container to your grandma so she can, you know, do stuff. What WM I'm using? Hey Nick, hello, welcome. It's Sway. It's also definitely not the case that updating ever introduces. Yeah, it never happens, right? It never happens. Definitely never happens. Fucking Linux packagers. How many human hours is wasted every day to dynamically link everything? Just imagine that. It's crazy. And I mean, you know, even if you want to dynamically link shit, you can just do what Windows people do. Just package fucking .so libraries and distribute them together with your software. Like, and you know, if you want to ship graphical applications on Linux, it's literally impossible to statically compile them. Not sure what the problem is. I mean, it is not a technical problem. The only problem with this is that package maintainers will just, oh, where is the instruction for packaging it to my distro? That's the only reason, because they will be super annoyed about it. There was like an article from that guy, like the hair guy, the one that got cancelled for like an inappropriate anime or something. He was like something. He was saying something like, make package maintainer life more like easier, provide instructions to how to like package your stuff for distros and blah blah blah. At least he wasn't really advocating for dynamically linking everything. He was just like, give us instructions on how to package your stuff, you know, so we can untangle everything ourselves. And man, all the cancellations were revoked recently. He's American, but he moved to Europe. And I think in Europe you don't get pardoned if you get cancelled. I mean, I'm kind of half joked. He's not really. He hasn't been cancelled. It's just, you know, it's a stupid drama, right? It's like usual. He said something about Richard Stallman, and GNU nerds got very mad, and they started digging, and they found something inappropriate about him, and they like. It's nobody cares. I'm just joking that he got cancelled because it's just funny to me how, you know. It was just funny, like he just like watched anime with little girls, and you know, just, people blew it like, oh, pervert. I mean, that's Linux community for you. That's why I hate fucking Linux. That's why I hate even the word like Linux community, as if it's not like a bunch of weirdos. Wasn't Stallman unironically? I mean, I would rather not get into that on stream, to be honest. It's not really something I was like, I want to discuss, but I'm not a big fan of Stallman. You know, he's definitely a weirdo. Like, it's like one of those guys who did a lot of, you know, he did a lot for software, but now he mostly like, he doesn't like provide much value anymore. All he does is like just complaining on Emacs mailing list. and making like life of maintainers harder. But I'd rather not get into his like political views. Yeah, I mean Terry is a completely different story. He was like an actual like genius. All my homies like Terry. And I mean, you know, it's like people are really weird about stuff. It's like instead of doing your own thing, people will like be terminally online and obsess about some like dude that's like completely irrelevant by this point, right? They would just obsess about someone instead of doing something productive. Yeah. Like Stallman report on or whatever. Like I don't care. I don't care about it. Just I'd rather do this. I forgot what we were doing again. I think it is a sign that I'm getting tired. But I think I still want to try and do this. Right? We got like two binary. Yeah. Here where it was. So we got two binary operators. So we get like this. Then we get this. No, we get this entire one. Then we get this small one. Then we get the right side literal. Then we get identifier. Right? Then we get another identifier. Then we get a binary operator. Wait, what? Yeah, ident, binary operator. So ident. I think this is the binary operator, no? I think it should be unary operator. Shouldn't it? 23, line 20. Oh. Why is it line 23 though? I mean, true, it is a binary operator on line 23, but shouldn't it be... Huh. Oh, no. So we get identifier here. And we need to traverse into it. So yeah, we get the identifier and it will tell us about unary or something. If I recall correctly. Right? So if I get to build, I get identifier and I need to get its expression and I check. Yeah, okay. That's fine. Yeah. So there's that. We can start here. I'll just get nodes until I get. I will get nodes if it's a binary operator. I will get a binary operator. Not even binary. I will get an identifier. Yeah. Which has an expression. Which will be a unary dot, a unary star. Yeah. People who are doing their own thing do not have time to attack. That's what I found, right? And I mean, don't get me wrong. Sometimes, you know, you just gotta call something out when it's really important, like, you know, like really important, right? I don't just say, you know, sit and do nothing always. Just do no. Sometimes there is important stuff that you need to do something about. Otherwise, if you just will sit and do nothing, your country will just try to invade another country, right? This is like an extreme example, but you get the idea. If you will be sitting too long, this will happen. But I mean, come on, fucking couple internet nerds like fighting over nothing. Over some anime waifus. Like, who cares? Who cares? Yeah, so right. Basically, there's two ways I found to detect an implicit dereference. First one is check if identifier has unary star from a different line, very important. And second one is detect a cast. So let's try that. And I think depth first kind of works. It gets like overall operator, and then it goes like small, right side, left side. Like it kind of does this. Let's also check. Oh wait, I do breadth first here. Never mind, this was breadth first. And let's check depth first. Yeah, it does that. Yeah, it does breadth because it doesn't go all the way to the left side. It actually goes all the way, goes left, right, left, right, left, right. Yeah. And if we get depth first, I assume it will be like it will be more like the declaration on the line 19. Did you read Algorithm Design Manual? No. The only book about programming that I read, I actually read 2 books about programming. Well, I tried to read multiple, but the only one I actually read was it wasn't like a clean code but by Uncle Bob, but it was something similar. It was something like Effective Programmer or Passionate Programmer. Fuck, what was that book? It was actually very well written. Like I really enjoyed. I didn't enjoy it as, you know, as a technical manual. It was just a very good read. Was it like Programmer Fanatic? What was it? Or was it like Pragmatic? Passionate Programmer? Was it? By Chad Fowler? No. Pragmatic Programmer. Yeah, Pragmatic Programmer. That was the book. I read it. Yeah. So let me show you. So that was the book I'm talking about. Yeah, I read it. David Thomas and Andrew Hand. Yeah, I read this book when I was in. It was actually after uni. It was like 2015, 2016, and it's not really a technical book per se, but it's a very good read. And ironically, like, it's just a good read. You know, you just read it's not a fiction, right? It's like, oh, you need to use version control, whatever. It's just very well written. I enjoyed it as a read. And another book I read was Elegant Objects by Igor Bugayenko. This is another book on programming that I read. Yeah, I was very OOP peeled at some point. It's actually also a very good read. This is a more practical one. It literally has, you know, like kind of cookbooks for how to manage your objects in a code base. Yeah, these are 2 only books on programming I read from cover to cover. I also read most of the domain-driven design, but I haven't read it through. And I started and kind of dropped a lot of other books. But yeah, those 2 I read from cover to cover. So yeah. So I am probably not the best person to, you know, get book recommendations from. So what do we have? Declaration, right? type instantiation, this, and then the declaration on line 20. So we have a declaration 25. Then we have so from 5 to 13, yeah. Then we have a unary operator on 2011. Okay. Then we have an identifier on 2012. So we descend into the right side. Then we have identifier on the 2012. Yeah, this one. Then we have binary operator 22.5. Where is it? Oh, this one. Huh. Wait, what? I don't get it. We have a declaration 22.5, 22. So we have the entire declaration. Then we have unary operator. And we have an identifier 2212. Oh, so I guess if you get a declaration, you don't get the left side. So here I didn't get even left side of a left identifier. That's a weird one. I guess you're supposed to get it from the instantiation itself. Let's check the line 22. That's the most important one. So we got a binary operator, the entire one. Then we got a literal. So then we get the right side. Then we get the binary operator, which is this dot. The 5. Huh? 5, yeah. This binary operator, 213. Then we get identifier on the column 8. So again, the right side, we get the right side. And then we get identifier on the 5. Nice. So this is kind of, we descend and we first fully explore the right side. Then we fully explore the left side. I think I like the breadth first approach kind of more. Although, so I will like, if I go depth first, yeah, so first I will detect implicit dereference, then I will go down. So I will, if I go depth first, I will be detecting implicit dereference first, like kind of top level implicit dereference, and if there are internal ones, I will detect them later. And if I go breadth first, I will be getting implicit dereference like kind of left to right in this sort of way. I don't even know what's better. You're in your closure phase. I mean, that's fine. I mean, closure is fine, to be honest. I like Lisp. I said that. I don't think Lisp is really a functional language, right? Because it's not like... I mean, it's not like Haskell or OCaml, right? I don't even consider Lisp to be a functional language, to be honest. Like, Lisp is just Lisp. Giant Book, Computer Networks by Victor and Natalia Oliver. I mean, books about networks are probably fine. You know, I remember there was like an Andrew Tenenbaum book about networks and about operating systems. I never read it fully, but I definitely had some useful chapters out of it. Tsodin used to be Haskell built. I actually remember that. I'm like, I know Tsodin since like 2015, maybe 2014. So yeah, I've known him for like 10 years at this point or something. So yeah, I remember, you know, Tsodin Erlang phase, like Haskell phase, Pacman in Emacs Lisp. I remember all of that stuff. I even remember Tsodin's Russian streams. This is how far back it goes. Not many people know, but he actually started streaming in Russian. Yes. It was a very long time ago, but I remember that. Actually, I don't remember if he like started streaming Russian or he like did few streams in Russian, kind of, you know, somewhere in between. But yeah, somewhere like early, like 10 years ago, maybe like 11 years ago, he was definitely... Yeah. No, I'm not talking about April Fools. I'm actually talking about the ancient... Yeah. I'm talking about the ancient times. Right. Yeah. Anyway, so do we like depth first approach? It's probably fine. Right, so let's try depth first and see how it gets collected, how we collect the identifiers. Ooh. So the income rate, true. So we need to go somewhere like, yeah, if identifier, right? So if exper.kind equals identifier, ident cast code ident exper yeah, then after we got like the identifier, we need to check whether it has a resolve declaration and expression. Yeah. So how do we do that? Expression equals fx identifier dot resolved declaration, then ident resolved declaration dot expression. If this is a null pointer, this will blow up. So I guess we do that. Then we get ident solved declaration dot expression. Yeah. But the real OG Twitch users know who Provat is. Why OG? I mean, he streams literally every time. No, don't do my boy Provat dirty. What do you mean OG? Like, he's literally the GOAT. He literally streamed yesterday. Here's, by the way, who we're talking about. Provat is like a very hardcore, like, GPU demo center, and he recently programs like Half-Life 1 ported to ray tracing engine, and I highly recommend his channel. He's very like chill and cool. His default streaming language is Russian, but he speaks perfect English, and as soon as somebody like pops up in the chat who speaks English, he would switch. Yeah. So definitely very, very good content, like highly recommended. And I mean, yeah, he doesn't stream like 20 hours a day, but I mean, what can you do? The only reason why I stream 20 hours a day now, I don't stream 20 hours, more like 2 to 4 hours a day, is because I like my family is like on a trip to Russia, and I'm alone for now. Do you think it's practical to learn Jai before public beta? I mean, of course not, Sol. Why would you learn a language that you can't use? No, not at all. It's you know, like, it's this learning Pascal with a pen and paper kind of deal. But yeah, Exper, right? If expr and expr kind unary operator. Because I watch you and John stream and I'm lost, but I don't know if I can really handle it without the compiler. I mean, you can ask, right? You can feel free to ask questions about the language if you're lost, but I mean, yeah, I don't know if it makes much sense to try to learn, like really like learn the language, right, before. And as someone said, you know, just learn the programming instead of learning the language. If you know programming, then learning the language will never be an issue for you. Unless it's, you know, some nonsense like Haskell. Or, you know what I mean. As long as it's like a real ass programming language and not someone's like fucking wet dream fantasy. Rust is fine, by the way. Clearmio, what language do you code in a day-to-day job? Oof. You ask that so every like single viewer like instantly leaves when I answer, right? But yeah. I do web stuff on my day job. It's like I mean, really whatever my master wants me to do. Like, if master wants JavaScript, I will do JavaScript. Master wants TypeScript, I will do TypeScript. Master wants Python, yeah, I will jump, you know. I even did PHP for a couple of years. So you can say that I tasted every single flavor of web slop. I'm literally web slop peeled. I never did Go. I never did professional Go though. I would probably be fine with doing Go. It seems like it's kind of sane language for web. Lotus grows out of the dirt. But yeah, I mean, this is such a weird ass out of body experience, right? I do an interesting nice clip. I do interesting systems programming on my side, and I have to do this web related stuff in my job, and it's such a big dissonance, man. Sometimes I'm really demotivated because of that. Hey Eric, hello. Sometimes I'm really demotivated about. I even thought, you know, just like maybe try to find some systems programming intern job and, you know, live off of savings for a while, just so I can, you know, do something interesting. Like, sure, I'll get nerfed, but you know, at least I will do something interesting. Yeah, I don't know. Yeah. But anyway, we get the unary operator. Op equals to cast code unary operator expr. And if UO operator type, right? So unary operator handles a type, and type is an actual like string for an operator, or rather like a number that represents a certain kind of type, right? So here's a char star. So this is like an implicit unary operator, and I guess we can also check and like UO dot location dot L0 is less than, so it's like previous than like ident that location that L0. So and what I mean by that is implicit dereference on the identifier is well, how do I write it without tautology? Is signaled by it having a unary star. that actually goes over from somewhere above in the code where the pointer is, I don't know, like declared, when the pointer is declared. Right? For example, no, I'd rather have it like that. So for example, we have A equals some struct, right? PA equals pointer to A. Here's actual unary star. And then we have B some other struct that holds some struct, or like first struct, some other struct that holds first struct, like other struct that holds first struct, and B dot A equals PA. Or no, how do you it's not like that. No, it's not like this. So the example would be, so we have a first struct, we have the second struct that holds, and then we have pointer B equals point to B, right? And then we do PB that A equals A, right? Here PB is implicitly dereferenced, and it's signaled by its identifier actual unary star is here. Here PB is implicitly dereferenced, and its identifier carries the star from the previous line. So does this explanation make sense to you, like to random people in the chat? You're working on open source cloud infrastructure. That's actually pretty cool. Chat. So it actually starts fine. Like chat works for a while, and then it starts dying and doesn't work anymore. I don't know. But yeah, does this explanation means, does it make sense for you? It's like why I'm comparing lines, right? That's why we're checking that the star comes from some previous line. Maybe we don't really need this check, but want to be sure. Like maybe I'll remove it. Yeah, and chat is streamed. That's unfortunate. I really don't know how to fix, because it starts out fine, right? And then it breaks. For you it makes sense. I mean, that's cool. Yeah, I'm pretty sure I even edited the CSS here. Maybe if I reset it, like hard reset. Let me just copy some message and see if it gets streamed. Boom. Yeah, now it doesn't get streamed for me. See, I just kind of reset the chat or whatever. Maybe I can use Bork, the one that Loris develops on his stream. Yeah, you see? Yeah. Just works. Fucking, I mean, Streamlabs, everyone. So yeah, if we have that, right, then we just say that, okay, we detected implicit dereference. Let me have probably an array, like dynamic array, derefs, like implicit derefs is gonna be a dynamic array of what, code node pointers maybe, right? Do we all we need is a ident enclosed load. So we need enclosed load. Oh, enclosed load is on an identifier. Yeah, it isn't. It is code node. So I start my English.exe is not responding. Podgorica internet. You didn't miss anything. I was just testing. I was just testing chat layout. Yeah. Didn't know you're from Podgorica. Get doxed, nerd. Code node. So on here I can array add it, right? So array add implicit derefs, and you're from Greece, but I have been stranded in I see. Well, I don't know, maybe lucky, maybe unlucky, depends on how you look, right? So we do identifier, right? Ident. Cool. And like type checked all we can. Machiavellian alloy. That's a cool username. Hello, welcome. Type checked all we can. We can just do what? For implicit derefs, we can just print if implicit derefs that count more than 0, we can do print detected implicit dereferences. Implicit derefs that count, and then for implicit derefs we'll be printing like this. We'll do file it enclosed load, right? And then we'll do file fully path file name, it location L0, it location C, like that. And I guess we can indent them a little bit. Whoa. Ah, freaky. I see. Windows people. Okay. What's that website people use for drawing? I mean, there's Figma, there's draw.io, right? The Blackboard. Yeah, Canva. I mean, it's paid, right? Excalidraw, yeah. When I said draw.io, I meant Excalidraw. Yeah. Thank you, artist. That's what I meant. So if we run now, what's gonna happen? We are just failed to compile. Identifier expert is used here, but shadowed later in the same block. Oh. If expr kind. Oh, fucking fuck. Look at this. So sub expression. And expr equals to boom. Undeclared identifier. Sub expr. Yeah. It's up. Cool. You have detect 7 implicit dereferences. Ooh, no, that's not good. It can't be 7. What? What? YouTube filters links. I wanted to show my BBS 4-player. Oh. Why does it filter links though? I didn't set that up. I would remove the filter, but I don't know how to do it. Yeah, I literally don't know how to do it. You can post it in Twitch, right? Can I post links? I can post links. Well, it's without you. It's twitch.tv/valigo, but you can post there. Yeah. It's 444.mo port 69. Okay, let me check first. What does it detect, and then I'll check out your thing. ptr.jai. So it says 22.5. Okay, this is correct. But why does it do 23.5? Oh, wait, no. But we have explicit dereference here. No, so now we get false positives, right? So yeah, this one is dereferenced. This is true, it is dereferenced, but it's dereferenced explicitly. I think you need port. You also need to do port. Oh yeah, you get a SSL protocol error. I mean, I can't open it with the port. Password is BBB. Oh, what? I can't open it. It doesn't open for me. Like, I can only open the main page with the rules. Yeah, but I can't. No, not website. But what's? Ah, telnet. Okay. Okay. So telnet. I don't even have telnet. Wait, what? Wasn't there just telnet package? Do I need to netcat it? Do you use like netcat for that? Yeah, GNU netcat, yeah. Can I like connect? Yeah, NC, yeah, just hostname port. Okay. So NC 444.mo 6900 couldn't resolve. Huh. Oh, it's 444s. Hey, welcome to chess. Press H. Cool. AA login is BBB. Unknown login. Do I need password is? What login do you need? Ah, okay. Do not enter it immediately. Oh. AA black BB. Ah, look at this. This is cool. That's fire. Ooh, oh no, I broke it. Fuck. And I can't connect to it anymore. No, I broke it. Yeah, I can't connect anymore. I'm sorry. It was good for a while. Anyway, it detects the reference here. I think I might have broken it. Yeah. Okay. Let me try to push through it. I get the reference in here. This is true, but it's explicit. But we detect it as implicit. That's bad. And then 2716. Huh. It gets detected, but it should be detected through a cast. Like this should be an implicit cast. Then 2916. Again, this is an explicit one. This is also an explicit one. 30. Yeah. And then 33. Yeah, PT. So it detects the references, but it also has a false positive for explicit ones. So this is bad. So we need to get an identifier. Oh, sorry for the. I don't have Visual Studio Code opened because I think I thought like I will need a debugger or something. So it gives me a unary operator regardless. Let me print vars on this bitch. Print vars. Like that. And let's check the ones that have line 23. Yeah. So line 23, we have an identifier. 23.5 here, ident on 23.5. Other one's 23.7. What? 23.5. 23.10. Okay, so we need to get, so we need to like, so we need to write it out. If it's depth first, it means that we get an operator somewhere here. No? Oh, I only print identifiers, so. Oh, wow. I commented out wrong line. Line 23, yeah. So we get binary operator, literal, and another binary operator. And I think I need to check that this binary operator is an explicit dereference, and after that maybe I will like don't do that. Oh wait, there is a unary operator, but it has the same line. What the fuck? No, that's bullshit. Wait a second. Wait a minute. No. Yes, it has a. This is correct. It has a unary operator. The correct unary operator, but I'm kind of going deeper. From YouTube, I guess netcat isn't telnet compliant by default. Oh. But I connected once. Right? I mean, I literally connected, and yeah, okay. It broke my terminal actually. Dash T. So NC 4444, there's mo 6900 and dash T, like that. Okay. So how do you log in again? I need new account, this and AA black BBB. Successfully authenticated. Now what? Empty. And now I can do what? Wait, can I get help again? I can't get help anymore. Q? I'm sorry, I broke it. Oh, wait, it refreshed. Maybe Q will work now. No, it didn't. Q exclamation mark. Let me out! Okay. Yeah, and when I Control-C it, you see when I Control-C it, it doesn't restore my cursor. Like it steals my cursor somehow. So I need to reset my terminal. We're play testing this shit. But anyway, I'm really surprised. Oh, you know what? I think this identifier always carries a unary dot. It literally always carries the implicit. It literally always carries this dereference, even if we explicitly dereference it. Right? I think that's what happens. So we had 23 dot where is it? 23.7. Yeah, we have a unary operator, and before that we get identifier on 10. So yeah, we have the right side. (23:15). So this is all. It's a binary operator. Okay. Okay, so if it is a binary operator, let me actually test it out. Like what it even is. If binary operator, so if subexpression kind identifier, else if sub-exper that kind equals to binary operator. Let me just record those operators. So like what do we even have? Op equals to cast code binary operator sub-exper, and then let's print vars, that motherfucker. Format struct op.star one true Yeah. So, and let's search for line 23. So this one is line 22. 61 is dot on line 22. So this is this one, right? Yeah, 22.5. Whoa, whoa, whoa. Ah, yeah, this entire dot is 20, yeah, 61, okay. Line 23, let's search for line 23. Okay, line 23, and we have also 61. So 23.7. So we get this dot on line 23.7. Binary operator. And we also get this one on 46. Wait a second. So man ASCII. 46. 46 is that, and 61 is equals. Oh, 61 is equals. My bad. So we have 46, which is a dot. 46 is a dot. Binary operator. So this is an equals. We have here we have a dot on line on 7. Here we have here we have a dot. Unary operator. Where's another binary operator? Oh, that's it. Oh shit. Wait, but this unary operator comes from the same line. No, that's incorrect. No, that's fine. That's fine, but so how do I prevent that from happening? I have a binary operator which is a dot, and then I have a unary operator which is a star. That's from 7 to 9, and binary operator is from 7 to 15. How do I combine them together? So I need to do it so that I need to do it so that I don't detect those. How do I filter it out? And after, so this is the right part. Unary dot. I see. So I get this unary dot, and only then I get the identifier. Okay. I think I get it. Right. So I get this dot, and even on top of that, so I get this operator from 7 to 19. This is the equals. Operator type 61 is the equal sign. So I get this one. Then I descend down, literal another binary operator. So from 7 to 15. So from this, so I get this dot. Yeah, I get this dot. I wonder why I never get this one. But yeah, anyway, I get this dot. Which is, yeah, 46. Okay. I recurse down, I get identifier from 10 to 15. Right, so I get the right side of this dot. Cool. Then I get some unary operator, and then I get the left identifier from 5 to 7. Let's also dereference unary operator and see what it is. Else if sub expr.kind equals unary operator, code, and this would be like 169 or something like that. And we get unary operation line 20, no, not line 20, line 23. We're looking for line 23. Unary, yeah, here is, yeah, okay, here it is. So 169 is dot star. Here we go. 23.7, 23.9. But why do we get both? We get binary operator 23.7, so we get a dot, and then we get dot star for the same one. That's like super weird. What are you guys talking about? About chess? About telnet chess? I see. So yeah. So what I need to do is I need to get this unary operator. And if I get this unary operator, this means that the next operator, the next one on the left, will actually be explicitly dereferenced, right? It's like if you get unary, you say skip next. And if next identifier, we skip next. But I mean, it might not be identifier. It might be literally anything else, right? Yeah. Same account for me. I'll have to read the rules, don't I? Yeah, maybe not today. Definitely not today. Maybe we can play like some other time. Today I'm too cooked. I see. But yeah, now I want to check if I can do this. Also, let me see if I want to try breadth first again and see if maybe this one gives me better result. Breadth. Yeah. So where do we get this unary operator? Line 11? What? Line 20. Okay. Let's see line 23. First, we need to check. We need to get. Yeah, we get the same results, exactly same results, and we scroll up and we get line 23. How do we get them? We get binary operator equals. Then we get binary operator dot. So equals dot, then right side literal, then we get unary. Oh, that's kind of cool. So we get a unary operator. Binary unary. After binary, we get the right side identifier, and then we get left side identifier. Oh wait, there's declaration? No, that's... So actually kind of... Oh, hey Kihao, hello. Hello, welcome. Good evening. Yeah, okay. I think breadth first is actually probably better. You definitely you got absolutely hacked by him. You know, you shouldn't connect to Telnet to unknown computers because they will take over your PC and will hack you for sure. Right. So if I got unary operator dot star, I need to skip an identifier on the left of it. Right? Yeah, on the left of it. All my anime vibes is in danger. You're right. The abyssal. I'm too cooked for this. Yeah, so breath first. Breath first. Won't let me say skip next. Or do you have unary? Yeah, unary 169, yeah. So if I get this, I want to say just skip the next skip next left side identifier. That's kind of what I want to tell it. Oh, you know, we have a sub-expression. Is this the same sub-expression? Wait, so sub-expression is 741b0. No, it's something completely different. Wait, do we have something? Do we have it somewhere? Oh, it's Control Y, yeah. No, only one. I wonder what's that. Wait, what the fuck is a sub-expression on... Sub-expression is some kind of a code note. What's that? Okay, let me get sub-expression. Op sub equals to op dot sub expression. And let's print is not a member. Oh, it's just sub expression. Right, so what do we have here? Some kind of identifier. Wait, line 20. Unary. Yeah, here we go. On line 23, the sub-expression is something identifier with 23. Oh, so that's it. We just need to skip, but why does it have a different address? Wait, I don't know its address. I literally, so op sub, let me just print this. And when I print identifiers, where do I print them? Print vars. Oh yeah, yeah, I want to print vars ident. There you go. So op sub is yeah, kind identifier. Wait, do I how do I? Oh, does it get dereferenced automatically? Oh, I didn't know that. Let me just print it without dereferencing. Without, I mean, yeah. op sub, and it's like that. So op sub. Yeah, okay. So we get sub node with this address. And where do we get ident? With the same address. So for is, yeah, that's the one. Okay. Look at this. So if we get unary operator of 169, we need to skip its sub-expression. Yes. Fucking got him. So if op dot operator type equals that operator type 169, it's called postfix dereference. Then yeah, I found the way how to skip false positive implicit dereference. I know that you don't care anymore. All you care about is fucking telnet chess, but if I knew that I would be programming telnet today, I would get a lot of stonks. Okay. Telnet chess and jive. If it's postfix dereference, so identifier to skip equals to well, op that sub expression, right? It's like node to skip. Yeah, node to skip. And let me do something like node to skip is gonna be a pointer to code node, right? And I guess we have a sub expressions here, right? And if sub exper equals to node to skip, then we do node to skip equals null, and we just continue. Will that help? Will it work? Unary dot dereference only match enum types, but here's trying to unary dot dereferences only match to enum types. Oh fuck, because it's a loose enum, so it's unary code unary operator dot operator oh, it's just operator type. Okay, so it's just like, bro, operator type. Yeah, there you go. No mismatch type. Fuck you. It's XX this bitch. Oh, it works. Does it work? We reduce something. Hey Lyndon, hello. Webslop. Who said Webslop? Welcome to the stream. Wait, where's Webslop? Who do I need to ban? Who the fuck advocates for some Webslop? Is Jumper Go Twitch IRC usable? I have no idea. You're asking chat, that's fine. Pasian spoke. 22. Okay, 22 is correct. Now 27, correct. 33, correct. And 34 shouldn't be detected. Yeah, 24 shouldn't be detected. So we're literally almost there. But why is this one getting detected? Why is this one getting detected? 22, correct. 27, correct. Oh, it has a unary stuff, but it doesn't have an explicit postfix. But this should be fine, I mean, because, right? Because this shit, this motherfucker accepts a pointer. But yeah, that's a completely different code path where we check for casts. This is also incorrect. It's like technically incorrect. I mean, no, it works fine. It detects unary, like this unary dot. Huh. What if we do test a ptr, right? And it's gonna be a pointer to a. And if I do like this, like this should be fine. Do we detect it? 29. Yes, we detected. This is another false positive. Yeah, we should check if so. If it's a right side, we should check for casts, for implicit cast. Right. If binary operator. So what's that? Yeah, this we need to. We can safely skip this. Let me remove the print. Let me remove this. Wait, not. So I need to port this code path. If kind is cast. So if we have an identifier, we kind of recurse here, but first we need to check for casts. Yeah. And then else if. Yeah. So first, if wait, not here. If sub expression is identical, so if sub exper that kind equals cast, and then else if, and then we'll literally just copy paste what we did, like that. Yeah, boy. Cast equals code cast. It's like sub exper. If cast flags equals this, then we just literally re-add this to implicit refs and cast. That's it, right? Oh, why does it detect 2? 28, it detects it twice. So 28, this is correct. Oh, it still detects 29, fuck. But now it detects 35 and it's still, wait. What? And why does it detect 26, 28 twice? So 16? Why does it do this twice though? Oh, because, yeah, because it kind of checks both. It gets the cast. And then I need to skip that. Let me actually print this cast, but without format struct. So I get this address and I can skip it. And yeah, I still print an identifier. So we get a cast. Look at this. Why is it? Huh? Why is it formatted? Wait, what? where do I, shit, because I'm printing a sub expression. Right. Let me go cast. Yeah, so we have a code cast with this address, and I assume we should be getting the identifier with the same address, no? No, we actually don't. So maybe the identifier is one of cast's children. Yeah, like an expression or something. Let's check cast dot expression. This one, FC50. Yes, look at this. Here's the identifier. Yeah. So if we do that, we array add and we do node to skip equals like clearly this. And oh, how am I stupid? It's literally expression. What do you not like? It doesn't like my typos. Duh. Okay. No. I mean, we deduplicate it, but it still detects stuff. I like how small jives friction, but in the same time, I hate the fact that I can forget some null checks for heap allocated array, and server will die after weeks of runtime. You know what's the trick? The trick is have null pointers be impossible in your code base. You know, watch that epic bit from Casey Muratori about zero initialization as default, when he explains that you need to have like a dummy field value that you can compare against, instead of checking stuff for null, or that you just can use. It actually helps a lot. It's just like a programming style. It has nothing to do really with language. But I guess Jai can help with, maybe you can operator overloaded or something. We have 35, 36, so this is I thought we skipped. That's a weird one. Why would we? So we add a cast, and after that we actually need to really skip the identifier. Yeah. Let's print the subexpression again to print vars. Yeah, cast dot one true, and then I also want to do cast dot expression. Right, so we get cast, we get the expression for an identifier, 2816. 2816. How do we skip 36? So okay, I get this 29. The way we remove it is by checking if it's like the right side of, if like left side of an assignment is a pointer. So I get how we check that. This is an easy one. I can just clean it up later. But why does it triggers on line 36? Because this should get skipped. So I get the cast, get this. Let me print an identifier like that. Print, so print ident, and we print the I then dereferenced. If blah 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 x per unary operator. Yeah, and I actually want to print it here. So if we go to this path, right? So I get cast. So line 23, okay, line 28, line 29, no, line 36 here. Oh, because it's not a cast. My logic actually works correctly. A GitHub? You can find GitHub in the description, like in my bio under the stream. Yeah. Do I not have it in Shill? Oh yeah, my Shill only has Twitter, YouTube, and Discord. Yeah. By the way, follow my social network. Yeah. So yeah. Okay. I only have false positives when I don't have like. Yeah. So the way I do it here. This works, right? But it's way too greedy. It's way too greedy. Yeah, it's kind of greedy. It's greedy as fuck. And the way I kind of avoid it is, so if I get like a sub expression, so line 29, for example, line 29 is, yeah, this is a false positive, right? If I print it, let's scroll to line 29, right? So I have a binary operator, and where is it? Yeah, so I have a binary operator which is equals on line 29. Then I have this like right side. This is the right side. This is the one I'm detecting, by the way. So it's 29, 20. Yeah. This is the one I'm detecting, and I need to skip it. And the way I skip it is, so we get here, and I need to check that previous one is a binary operator of equals. Then I know that my identifier is on the right side, right? Then I can sort of check that my left side, oh, and then I need to recurse like all the way to see that this is just a pointer, which kind of sucks. Kind of sucks to do that. Yeah, I mean, I see exactly how to do it. It's just kind of involved. Well. Can I maybe... So I think I will only check the unary dot when I am in this situation, when I am literally on the right side of the dot. I think that should work. Right, so this one has a dot on it, like unary dot on it. Yeah, thanks for hanging out, Nick. Thank you. I'm also like close to done. I think I'll be literally winning soon. chat overlays fucked again. Okay, maybe some symbols do break it. Maybe some symbols actually break it. I mean, it's Streamlabs. What can I do? Like, Streamlabs fucking dog shit. Bad. Me no like. If anyone knows good chat overlay that supports both Twitch and YouTube, feel free to let me know. Like Bork, the one that's like Loris works on, is pretty solid. It's also terminal based, but it only supports. Oh wait, actually I think he added YouTube recently, so maybe I can use it instead. Yeah, we'll see. Yeah, I restarted the chat widget. It should be fine for a while. Yeah, so this is what I'm gonna do. I'm going to only check for this unary operator when I am on the right side of a dot. Hell yeah, brother. And I know that, yeah, okay. So I have a binary operator, which is a dot. So how do I do this? Right? Well, first I need to resurrect this part, like else if sub expr.kind equals binary operator, right? Code binary operator. Code binary. It has right side. Yeah, right side. So, and we can do. It's not like node to. If this equals to char dot, right? If operator is a dot, then we need to check equals operator dot right. And if right is an identifier, then we check it. So when we go here, kind is identifier and sub expr equals to need to check, node to check. Then and only then we do that. And node to check is a code node. Oh, now we're okay. Now we only oh wait, why doesn't it check for casts? Shouldn't it like, shouldn't it be fine or what? So it gets this one, it checks it after dot, that's fine. Why doesn't it check this one though? Huh? Print vars format struct op dot one true. Line 23, binary operator. It is a dot. Yeah, 61 is a dot. Oh, 46 is a dot. What's 61? Equals. Okay, this is an equals. Fine. We descend further. Here's 46 is a dot. Yeah. 23.5. 23.5, yeah. So it starts here with a dot. We have 61, which is an operator equals. I'm printing too egregious, I think. No, sub-expr. No, okay, not quite too egregious. Yeah, all right. So 23, 5, 17. 23, 5, yeah, that's the one. Then we get another one. Then we get this dot. Yeah. I'm surprised that we go to the left first. But yeah, whatever. We get literal. Cool. Then we go to an identifier. This identifier is... yeah, two identifiers. One on the left, one on the right. Huh. So right is this, left is this. I wonder why don't we catch them? If an identifier, where do I print ident? I'm not even printing the idents. Let me remove that first and see. 23, 46, yeah, 46, okay. Literal ident. So EB00 PA. Where's a int? Oh shit, we don't get it, do we? Huh. So we get this one, which is the left one. Why do we literally skip it though? I'm surprised that we skip the right one, like completely. Oh wait, no, it is dot. A int. Oh, a int is a, okay. Yeah, the pointer that gets dereferenced is PA. Not right. I need to skip the left side. Yes, sorry. This is like, I mean, this is me just getting tired at this point. It's like been 5 hours, yeah. So I need to, well, first get that, and I need to check not the right side, but the left one, because the left is the one getting dereferenced. Right, and when I do that, I get 23, 28. Okay, we're close. This one on 23 gets correctly noticed, and this one on 28 as well. And I need to get back my 35 to 36. And the way I get it is by checking whether we are in a procedure call. But I think this should be fine, because this should technically be a cast. Is it not? So let's check line 35. Procedure call. Oh, if it's a procedure call, I need to descend into the arguments. Cool. So I actually implemented that already when I experimented. Not procedure call, fuck, build. Here, if we are a procedure call, right? So it's here, yeah. So if we are a procedure call, so if cast, if identifier and check, binary operator, unary operator, and a procedure call, here. Let me indent it properly. we cast not statement, it's gonna be sub expr, and if sub expr kind is a procedure call, we cast the procedure call, we get the arguments, and we iterate over the arguments sorted. And if kind is cast of an argument and we get the cast, then we just array add implicit dereference and cast. And now we call, and yeah, this is what I was talking about. We get everything in our reports, 23, 28, 20, 35, 35, and so line 23, we dereferenced PA implicitly and assigned to A int something. This detects. 24 is fine because we explicitly dereference PA, right, and assign stuff, so we don't detect it. Now we initialize a bunch of stuff, and on line 28 we have test A being implicitly dereferenced because we assign a pointer to it, right? And if I add that and do this, this should be fine, right? Yes, you see, so this is an implicit dereference of PA pointer. We dereference it and assign to test A, and we detect it. Here we go. Column 16 is this one. Yeah, literally on the identifier. This is an explicit dereference, so we should be fine. Yeah. Next one is I assign pointer to pointer on a struct. We detect that it's fine, totally not an implicit dereference. These two are both explicit, right? We have test B, which is an integer, and I actually dereference PA and get A int, which is fine. Explicit dereference should be, yeah, okay, we get, I wonder if we detect, I don't tested it, but what if we do test B and we do PA that A int? So here PA gets implicitly dereferenced, right? So this should be detected. Will it though? On line 33? Hey, look at that! A test that I didn't have coded manually, just via a virtue of code visit and some cool logic. We literally detected that on the line 33 we implicitly dereference in PA. Yeah, on column 16, cool. This is skipped because we dereference it explicitly. And then line 37, yeah, gets detected because we implicitly dereferenced PT, because test procedure accepts a struct, not a pointer. So here it gets like dereferenced. I mean, I still wonder if it actually what happens, because you know in Jai structs get passed maybe by reference. So maybe, I mean, maybe that, like, the language says that this is an implicit cast dereference, so we just trust it. And this is fine because test2 accepts pointer and we pass a pointer. Yeah, this is great. Oh, that's literally it. So, and let me clean up the build script a little bit. So after the continue, I can remove all of that. Boom. And I mean, minus the debug prints. Right, let me just comment out. Right, let me just comment stuff out. Ooh, these are commented out. This I don't need at all. Yeah, and there you go. Yeah, I compile the stuff, and I get 4 implicit dereference detected. And if I remove main, I should get a lot more if I don't crash anywhere. Yeah, so basic print. So it only detects implicit dereference in the code I'm using. Let's actually check if basic print indeed dereference stuff, or it's another like false positive. So basic print.jai 792gg. Print array, it passes a builder. What is 48? 48. 8, format. So format is actually a pointer to a format array. And what print array accepts? 1, 2, 3 format. Oh, and it accepts format array, not as a pointer. Look at that. I mean, it is a struct, but we pass a pointer to a struct that gets implicitly dereferenced. Hey, this is legit. This is legit dereference. Nice. 755. Check null for matter. What do you pass? 41. So this one, format, again. Yeah, cast to a pointer to format struct. Yeah, so check null for matter accepts, yeah, for matter, and it gets implicitly dereferenced. Look at that. Again, I'm not sure how valid implicit dereference in case when we pass a struct, you know, because of maybe by reference, but I mean, the compiler tells us that it is an implicit implicit dereference, so we just trust it. Maybe it makes sense to exclude procedure calls because they're kind of special, but we'll see. 780. Yeah, I guess it does the format, which is a pointer to the struct, and 779. Wait, what? 779. Ah, yeah, check null for matter. Yes, for okay. Yeah, I mean, these all of these are dereferences. That's great. I mean, we're fucking balling. Technically, I would like to test if it detects kind of multiple in a row, right? So these are cool cases, but they don't have like chain of calls. And so, for example, if I have test has A. And if A has int like PTR, right, like pointer to int, for example, or maybe not a pointer to int. So we have test dot test A, like that test PTR dot A. Yeah, what if we do something like t dot test a ptr dot a int, like this, right, equals 5. So this should be detected because test a ptr is a pointer. Line 32. Do we have it? No, we actually don't have it. Because what? This left side got excluded for some reason. So yeah, I guess we don't handle nested types. Maybe because I add it to excluded case and I shouldn't. But this should be at this point this should be relatively easy to debug and fix. 35. Yeah, this is correct. But this is not. And what else? This is another one. So TP is like a pointer to test. If I do TP, will that be detected? No, it's also not. So this thing doesn't get detected. What if I do test A equals to PA dot like that? 33. Okay, so this doesn't get detected because so this is a test pointer, the test A. This technically should be detected because it's a segmentation. I'm not even looking at it. We are segfaulting, but why are we segfaulting? Excuse me. Oh, it's like a type. I'm not even I didn't even initialize it. But I mean, technically it should detect the TP is a pointer to test that test A. Like it gets dereferenced. I think it should be detected still. But even if I do like pointer to T, I don't think it will get detected. Huh? Like that. No, it gets detected. Look at this. It literally gets detected. That's fine. But I think it should also detect when I just assign it as a... So if I just declare it like that, I think this should be detected. So that's something to work on. So we detect it if we actually assign a pointer to it, but we also need to detect this situation. So it's like really close. And then that star that is making I don't know, I like stars because it just makes it symmetrical, right? You have star on the left, address of, star on the right, the reference. It's just very consistent, right? Like if C had this as an address of, or maybe that as an address of, I wouldn't mind it. 2 gold stars. Wait, what else did we have? What else did I want to detect? All right, let's like T that test A P T R equals to test ptr dot a int equals 5. So this also should be detected, right? This should be detected because test a ptr gets implicitly dereferenced because it is a pointer, right? It is a pointer. It gets dereferenced. I think it's gonna just segfault, right? Yeah, it's just gonna segfault, but where? Where does it segfault? No, it's not it doesn't segfault, but it doesn't detect either. I think this should also this should also detect, right? Because we have test a pointer, which is a pointer to A, and this gets dereferenced before we assign that. Actually, if I so we do test APTR is pointer here. Yeah, so we initialize it properly. I think if I don't do that, it explodes, right? Does it? Yeah, it will explode if I don't initialize it. But I mean, regardless of whether it explodes or not, it should be detected. So I need to see where I break my chain, which should be relatively easy now because I don't have a deep nesting. Yeah, I think that's like a relatively successful experiment. Maybe it's not even, maybe it's just will be generically useful, right? I'm gonna probably like brush it up, just check where, like, why am I giving up on an identifier or not? Actually, I think I know why I'm giving up on an identifier, because this like node to check is excluding too many of those, right? So I'm getting the binary dot, right? And I say that, okay, I need to check the left side of it. But I think the issue with that is that right, so I get like this binary dot or something. Or maybe I get this binary. So I probably just skip too much of the subtree. I probably need to verify that the left side is actually an identifier. Right, so... Right, if operator type equals this, and maybe... Let's just YOLO it and see if it helps. And op that left, that kind equals to ident. Will that work? This is just YOLO. No, I don't think it helps. Right. So this should be detected on line 32, and we don't get it. Yeah. Okay. So this doesn't really make any difference. Yeah. So I'll just need to see why am I skipping too much here. Right, because I might not be getting the dot I'm looking for, but overall it's great. Apart from like deeply nested dots, it all works. I'm pretty happy with the result. Another metaprogramming W. I yapped a lot, probably out of 5.5 hours, and I think I worked for like 3. Maybe I will make a YouTube video out of it. We'll see how it goes. Anyway, let's maybe find someone to raid. We got a couple raids today, which is pretty cool. Who's streaming? Oh, our friend Kolonk streaming. Kuju we raided just recently. Yeah, we'll raid Kolonk, our epic Lisp friend. So let's raid him. Yeah, okay. Thanks everyone for watching. I really appreciate it. Here's my shill link. Like, follow me if you want. Discord is where I post notifications when I go live. And yeah, I'll see you all next time. Goodbye, people. Have a nice day.
Yeah, so basically the concept is there's just like